Good evening, Manana. I hope I am audible.
Yes, Selena.
So, welcome to the Day 4 of Faculty Development Program organized by Department of Computer Science, Nirmala College, Watford. Today, we have two sessions. The first session will be on the topic Cyber Threats and Vulnerabilities by Mr. Suresh Kumar DS. And the second session will be on the topic AI and Data Science with NILE, a novel low-code open source platform by Dr. Vivian. Once again, I welcome all the participants to the meeting. Without any further delay, let's get into our first session. Let me introduce the speaker of the session, Mr. Suresh Kumar VS, who is a senior technical lead at Bosch Global Software Technologies Private. He has completed his master's in computer applications from Mahatma Gandhi University. He is having more than 18 years of experience in IT industry and work in the area cybersecurity, architecture design, reviews, application development, data analytics, and data visualization. He will be talking to us about cybersecurity, threats, and vulnerabilities. Sir, we are very grateful to have you with us. So, happy welcome, sir. Over to you.
Yep. Thank you, Alina. Thanks for the intro. So, one thing which I think it's missed out, and the important one which is missed out in the intro was that I am also a student from Nirmala College. So I'm very glad that I could be here with all my teachers. So it's a happy moment for me, actually.
Yes, Suresh, I was going to mention that. And we are also really happy and we are proud to have you as our resource person for the day. It's a moment of achievement for us also. Having a student with us as alumni and as a guest speaker is something great for us. So thank you so much for joining us and over to you.
Thank you, ma'am. So yeah, hope my screen is visible to all of you.
Yes, Suresh. Yes.
Yeah. So today I would just start with a small image, which hopefully we all are very familiar. For me, this is more familiar from the movie Titanic, the analysis of Titanic accident, and from there it is visible how it was, all those things, right? So for me, today what we are discussing, I would resemble more towards to this one. So we are just discussing about the cyber security. So whatever topics I'm going to cover today, it would be just the top part, what is visible for us. But the cybersecurity as a domain and as a learning part or academic or as a career, it is something here. It's very huge. It's very vast. So yeah, so don't think that, okay, whatever I'm saying today or what we are discussing today, that's all cybersecurity. No, it's just the tip of the world. So yeah, so without much delay, so today our discussion would be mainly about the threats and the vulnerabilities. So threats, we know what it could be, the different harmful activities or something like that, we can say. And vulnerabilities are something like what we missed out during our implementation, so during our operations. So we will discuss about that, and which actually is the base for all sort of cyber security attacks what we hear in this world today. So first of all, getting into that, I will just try to point out something here, which is like public CSC0. I'm not very sure how many of you are aware of such indications. So this is something that it is very interesting and very good to know in much earlier stage of our life, because these days we are into the cyber world. So what is this? What are these classifications? So basically, this is actually a data classification. So data classification SE0 means it is public. Anyone can see that. It is defined in that way. To whomever we could share it, something like that. And something is there SE1, which would be something very internal to an organization. So even it could be a company, or it could be a college, even could be our family. So our WhatsApp groups is one of the examples. So where we might have WhatsApp groups for our family, and also those communication, whatever happens inside that should be treated as internal, so SE1. And the one like SE2, which is confidential, yeah, as the name suggests, the information which could be utilized or exploited by somebody else in an ill manner, those all could be classified as SE2. So those including our bank account details for sure, something like that. And the highest one will be the SE3, which is highly confidential. So that basically is our healthcare informations. So our medical, maybe discharge summary document where you have all your personal information along with your medical illness related things and everything. So as a first step in the cybersecurity, we should be aware of how to classify our information and what need to be put where. So because we are mostly into too much exposed in the cyber world. So that is the first thing. So maybe as a practice, you can start doing that, classifying your information and think about before posting anything into the cyber world, think about whether should I post it? Is it my SE1 or is it 2 or is it SE0 data? So based on that, you can actually plan things. So let's, without much delay, let's start into the topic. So yeah, so one briefly we would be covering today would be like, I'll just give an intro, like what is cybersecurity all about, the common threats, what we are dealing with as an organization or as an individual, whomever it is. What are the common threats, what we face inside the cybersecurity, the impacts of the cyber attacks, the vulnerabilities, how those are getting exploited, some examples of some cyber attacks, and the best practices, what normally it is used inside the organizations, as well as maybe organization, as I said, the definition is only a company or something like that. It could be even a college or university, whatever it is. Then today's world, what are the tools and technologies that normally use? Then the main time will be for a Q&A session. So yeah. So let's discuss what is cybersecurity. So let's just 1 second. Yeah. Cybersecurity, that's the word cyber. What is cyber? So cyber, you'll be knowing that, okay, it is anything that could be a connected world where the systems, humans, the networks, the whole things, whatever is virtual, it's all comprised into digital world. That is called a cyber. And the cyberspace is somewhere where we all keep all our devices, including the mobile phone. So that is cyberspace. And what does the cybersecurity mean for? Cybersecurity is actually a practice where we are protecting these devices, the data which is generated from the devices or stored in the devices, from any sort of external attacks or the damage or threat. Damage in the sense your data is getting modified or something like that. That is what actually cybersecurity deals with. So the main goal, what we look in the cyber world is that, okay, we call it as CAA. It is something like confidentiality, integrity, and availability. So this is the core of the cyber world, and this is the core of what we are supposed to protect in the cybersecurity world. So with the confidentiality, it is actually what it meant is that, okay, keeping your information private. So like, for example, would be like your emails and whatever it is in the Gmail or whatever, Yahoo, whatever mail servers. It is confidential. We are trusting them as confidential just because, okay, it is kept in a place where an authorized user only is allowed to access them. So in that sense, we treat them as a confidential information for us, or making the confidentiality. Anything breaches happens into that system. Even because of any human errors or because of any misconfiguration in the Google or Yahoo accounts, it is again a threat to the confidentiality part. So the cybersecurity mainly looks in the confidentiality, then the integrity. The data, whatever you are storing there, it has to be that. It should not be getting modified. So many of time you might have seen that whenever you're downloading something from the internet, they normally says, okay, ensure that your checksums matches. So it is something like, it's a method of a tool which is used where you are ensuring that whatever you have stored there, it is intact there. So that is the another major goal we will be looking for in the cybersecurity world. Then it is availability. So information is kept there. It should be available when it is needed. So ensuring that the systems which is providing the information, it is available whenever it is needed. That is a third goal. Then why it is so mattering? It is like, okay, as we know that, okay, today's world, all of the information, it is like, it's too much of computerization had happened. And nowadays it is not computerization, it is digitalization of the data, including our Aadhaar, our health data, everything is actually stored in a public space. We can say it in a public space. Public, what I meant by public space is something like it is not accessible by everyone. It is, but something like it is can be accessed by anyone if it is not secure. So protecting those secure information is one of the why we need this, and obviously preventing this attacks like hacking, phishing, malware, ransomware, all those things attacks, and ensure we have a safe and reliable technology in hand. But then, where all these particular goals or all those things matters there, we think, okay, it is only applicable to huge enterprises. It is only for that. But actually, no, it is even for a common man, even to his common personal devices like the mobile phone itself. It has the data, and the cybersecurity is applicable there. So what we are protecting using the cybersecurity is either the personal devices, the corporate network for sure, and the data and the infrastructure behind the corporate networks. Then the online solutions or systems, whatever we have today, all the digitalization as such, we can think of. That is what we have to protect, or the areas what we are supposed to protect there. And we never should think that, okay, cybersecurity is, okay, we have someone like a cyber wing in the police, it's their job, they will be ensuring the protection. Not like that. Or it's not an organization who, there is a team who is behind the cybersecurity. They are the guys who are to ensure that everything is secure. No, it's not like that. Cybersecurity is essential for everything, and it is actually the responsibility of each one of us to ensure that whatever goals we are saying, it is achievable and can be achieved. So in very simple terms, what we can say is that, okay, just like what we think about the physical security, like in our home, or we are locking the homes and everything, right? A similar way, it is actually your digital information securing it in the online world is actually what cybersecurity all about means. And what it protects, as I said earlier, all the devices, your data generated or saved inside the devices, that is actually getting protected. And to what or against what actually we are fighting. So we are fighting with, again, something like the software or something which is actually created by ourselves itself, like it includes the malwares, the ransomwares, the phishing attacks. We will get into details what all those things are there. Then, as I said, the human errors by which unauthorized access and all those things is possible, and we are working towards that, how to secure those things. And for this, obviously, yes, we have different technologies in use. We have the different processes, different frameworks are there, different laws are there, which is supposed to be get followed. And yes, obviously, at the peak of the all the one, it will be the people, the individuals. They are their good practices which they follow in their life actually makes it the whole thing in a secure way. So that's all about the cyber security, what it is and what we are trying to protect there. The next is like, okay, why it is so mattering. So as I said, today's world, all our data, as you know, the cloud storage, everything, applications, everything is hosted in the cloud and everything. And if you know, even the banking information, all the informations are actually, even though it's not stored, example, banking, it is not stored, but yes, it is actually traversed in the cloud environment. So protecting all the sensitive information is one of the major goals. Then the integrity of the data. When there is a lot of traversal happening within the world, like you are accessing from your home, your internet banking or something, your banking accounts are stored somewhere in a bank server, which should be somewhere sitting in Mumbai or somewhere in Kolkata. Then from here to there, the data traversal through many nodes, these data are getting traversed, and there is a chance that okay, your data would be getting compromised in any point of time. So that's why we are saying it need to be protected, and this need to be practiced, the cyber security to be practiced to the depth. Then, yes, obviously, as I said earlier, it is just not an IT issue. As I said, cybersecurity is not just an IT issue. It is essential for protecting everything. As I said, for example, take an example of a university or a college. So there, do you think cybersecurity is required? I would say yes, it is very much required, because in a college or school, if you look in the basic data, what we can steal out is students or even the faculty's personal information, even from their date of birth to their personal address, their phone number, whatever it is, everything is actually kept there. And if it is not secured, yes, that is the best place where we can take the information leaked out from that. Then maybe I think now in India it is not there. Maybe in India also it is getting established. You might have heard about DPEP. That is something like sorry, DPA, not DPEP. DPEP is our education system holder. So DPA, it is actually a law where that how the data need to be protected and the data to be how it need to be kept private. The privacy part of the data laws are getting formulated. Once those are there in the place, then whatever you're seeing today, this whole will be getting changed. Is how our social media works, how freely we are navigating or we are accessing the data. These all will be getting changed. One best example would be the GDPR, which is almost 10 years before it is implemented in European Union. It is actually meant for that. Their European citizens' data, how to protect that and how to ensure privacy of the data is there. So like that, laws would be getting coming in, even for India also. It's starting phase, it is happening. So once those things are coming in, then why the cybersecurity is required, that is going to be matter the most. So yes, as I said, what we are actually dealing here would be protecting the sensitive information. As I said, in a college also, the student records, many of the universities like IITs and all, they do a lot of research. These researches are actually the seed for the innovations, whatever is happening in tomorrow's world. So these research data are also treated to be as very confidential information. And most of the time, these theses and all will be left inside, maybe in the office room, and which is to an extent accessible to anyone who will have to enter into that office room. So even in digital world also in the same way. So these type of sensitive information is what there which we unknowingly leave it. So protecting those ones. Then the academic integrity, like you might have heard about a lot of online exams and grades are happening, and even I think our 10th and +2 students mark list and all are getting published via online. And I think 2 or 3 years back there was a controversy came up that okay, somebody has changed their marks in the online way. So something like that is possible. It means the integrity is actually getting affected there. Then the financial losses. As I said, the best example, again, I can quote is that recently what is happening in the Jaguar plant in Europe, there is an attack happened on their entire manufacturing infrastructure. And to avoid further propagation or transferring of that attack, what they did was they simply shut down the system. So it is been now almost 1 to 2 weeks actually. And till now, the plant is on down. It means how much financial loss that is going to incur to that company. You can just imagine it. What I read was like per day, these whole manufacturing plants together, they were actually manufacturing around 1,000 cars in a day. And these many 2 weeks itself, 15 days, you can understand how much is a financial and the business loss, not only to them, their suppliers also will be affected because they also will be manufacturing for them. It will be just done there because no further manufacturing is happening from the main OE side. So financial losses, what will happen? Then, as I said, safeguarding the research and innovation. As I said earlier, an example like how these universities or colleges are creating innovations, they are filing the patents and all those things. The similar way, each organization, they are doing the same way, like they are also researching a lot and they are filing patents. Patents is one of the, I would say, like one of the major revenue making part of any organization. Because of the patents, many of the companies are surviving now also, and they are making a huge amount of revenue out of that. So even I could quote my company. My company is also having a lot of patents. We generally say that across the globe, we file minimum 3 patents in an hour. That is the average in which we calculate our patent filings. None of the all the patents may not be, or filings may not be getting into a patent. Very few will be getting rejected. It's there, but still that is a volume one company generates. So you can imagine how the other companies are generating the patents. So yeah, then the other major one is something like, okay, complying with the legal requirements. So for an university or a college may not be that so critical, but when somebody is into the business, then complying with the legal and the regulatory requirements is very must. So one example, as I said, was the GDPR. If in case we are failing there, then it is, I think it is around 4% of the company's turnover to be kept as a fine. So like that, that legal requirements need to be kept in there. So that is another aspect why it matters a lot. Then maintaining the trust and reputation. So any organization like a bank, for example, if they say their customer data has been leaked out, then you can imagine like, okay, how many of the people would be further be there, or any malpractice happen via online, if they say, then yes, you can imagine what is a trust that is getting impacted to that. One reason one will be like our opposition leader, he had raised an allegation that, okay, somebody online, they were able to remove few of the electoral or modify some of the electoral things in some constituencies. So you can imagine like a common man, if they heard about that, okay, do they believe in this current system? So these are something what is way in which this cyber attacks or cyber malpractices can impact on any nation or any policies or anything what is there. So the trust and the reputation that would be getting affected. Then for an university or a college, you can just imagine like, okay, if you have generating a lot of innovative things in your universities or colleges, then yes, it supports a digital learning environment. So I could say these are the major aspects why we should actually consider cybersecurity as a must. So moving forward, I would say again, with some financial aspects, I quote it here like, according to the Gartner, Gartner is actually an organization who benchmarks a lot of things. So according to the Gartner, in 2025, they are estimating that by end of 2025, they are estimating that the cybersecurity spending by an average organization is going to reach around 2013 billion dollars, which is a significant increase or significant amount also. So you can see here, like in which all areas actually these cyber attacks are more happen, the verticals. So mostly happens on the financial services for sure. The Bitcoins is the best example. And then the government and civil services. Yes, that is another aspect. It could be individuals or it could be another country. They will be doing that. Okay, it's not for me. So then, yeah, tourism would be there. Okay, so service providers and the media, healthcare, utilities. You can imagine whatever industry vertical we have been heard about, almost everything is affected by that. And as I said earlier, you never should think that, okay, it is only affecting a huge organization. No, never. Huge organization, it is easy. A small loot, you will be getting a maximum profit out of it, but you can extract more basically. But then, according to studies, it says that 43% of the attacks happens on small and medium business. So all sectors across the scale, it is affected. And you can see here, like this part, like how the growth of the crime cost is cyber crimes are happening. So 2025, it is calculated to be 3 trillion. Then by end of 2025, it is supposed to be at around 10.5 trillion. So that much, what is that? The global cost is actually happening into the cyber crime world. Then yes, why it is actually increasing, or why this is increasing like this? Because there are a lot of technologies came in, artificial intelligence came in, then why can't we stop all these things? People might be thinking. A lot of security measures like encryptions and this thing, that thing, a lot of things are in the world. Why still we are telling, okay, it is going to be increasing, it's not going to reduce? We can just start with an example of something like, according to studies, in the recent studies, what they found that the frequency of the cyber attacks has doubled post our COVID-19 pandemic. So the reasons are very evident that, okay, it is something like we say, the necessity is the mother of inventions. So people want money, they can't go out, then they will start thinking what are the other ways I can actually start earning money. So that is one jovial way I could explain that. So people start thinking there, humans are more brilliant, more capable, efficient. So they identify new ways how they can actually earn money sitting in their home. And they started doing small attacks and small things, and they started to get money, and then they found, okay, this is a good business. I think when I say individuals, you can also think that, okay, due to the COVID, many small or big organization MNCs are actually got shut down because of the different reasons it was got shut down. And many of them has replaced their technological area, and they are still surviving. And many of them was found out, okay, they are into the cyber industries now. And what normally they do there is actually they are actually looking into the cyber attacks area, and they are actually making money out of it. I'm not saying these all are illegal or something like that. It's legal way also we can make money out of the cyber attacks. For example, is hacking. So there is something called ethical hacking, and a black hat hacking or something like that is also there, which is what normally we heard about. People comes and they loot the data and all those things. But in an ethical hacking, it is the other way around. You spend your efforts, you use different tools, you get into the different applications or sites or whatever it is available in the cyber world. You actually assess those applications and you find out the vulnerabilities. And with the proof, you are actually allowed to report them to that organization. And they are supposed to provide you remuneration. So that is also in a way, in a very straightforward, as an individual, I could sit in my home and I could do that. I can also earn, but it's not a simple one. As I said, it is a difficult one, but hacking had become an industry thing where people also started doing this and they are making money out of it in a legal way. Then the next main reason why it has been increased is actually the artificial intelligence introduction. So previously, we normally say that there is something called a threat vector. We call it in that way. It is like a permutation combination of different aspects like threats and vulnerabilities and how these are possible to happen. Like that, a normal way of calculation was there. But then with the evolution of AI, this has drastically changed. Drastically changes in the speed in which the attacks are possible. One simple example I can quote is, we normally say a data which is encrypted, it is safe. But then the earlier days, it was only a 16-bit of encryption. What was happening? 16-bit of encryption in the sense you will have a ciphertext of 16-bit or 8-bit or 16-bit like that. And you will be encrypting data along with that ciphertext. And what happens is that once that data is generated, that is would be a meaningless data for anyone. Okay. Like meaningless data. And what happens is that after that, even if it is available in a public way, yeah, nothing is going to happen. So what normally happens was, in any development environment, people normally used to keep their credentials in such a way that, okay, they encrypt it, they store it there, like a username password of a database, for example. They store it in that way. It will be encrypted. It's safe, actually. Safe in the sense, the standard wise, it is safe. You could do that to an extent. But then what happens? The theory behind it was, okay, it is a 16-bit or 8-bit, whatever it is. It takes this much time and effort and resources to identify what is that combination of that we call a SARIC. Okay, it is that 16-bit that we call as a SARIC, the cipher one. So the cipher, how much time it will take to predict and identify it and then decrypt that one. That is the normal way of thinking. That's why we used to keep the 16 and all in the early days. But once this AI is introduced, that has been drastically reduced. The computing power has increased a lot. Then it found that, okay, 16-bit is not sufficient. They stopped all the 16-bit. Now the standard is somewhere like 256. It is mandated to have that. 256 should be there. But then just increasing the cipher into a 256-bit, it is not, we can just say, okay, just increase it to 256. But the infra, what is required to encrypt those data, it could be a vast amount of data. To encrypt that data, decrypt that data, the device capability, the resources that is needed in the end of the communication, the devices, whatever it is there, then that will also need to be increased. So the cost obviously would be getting increased because of that. So artificial intelligence, then you might have heard about PQC, post-quantum computing. So now, once these post-quantum computings are available in public, till now it is in the research areas. Once it is there in the public, then even 256 won't be sufficient. You have to go with 1,024 like that. It need to be increased. So the cost, this is some factors why the costs are getting increased. Then, yes, as I know, in the COVID time example again, we were mostly working in the remote. So remote in the sense your data are getting transmitted. So the chances of getting breaches was very high. And just imagine the business impacts that could bring in. As I said earlier, this many laws are there by which it is made it mandatory that if in case any violation are happened within an organization, like a data breach happened, for example, like Google, a data breach happened in Google, then according to the country's law, example, I could again quote like the GDPR, then as I said, it is around the 4% of their yearly turnover is going to be the mandatory fine that need to be filed. And it is by law, you have to do that. So due to all these things, how organizations are also tackling it. Obviously, they would increase the budget. They have to increase the budget. They will increase the budget on the resource front. They add to new resources, everything, or increase the capacity of the systems, whatever they were in the place. Obviously, that is going to increase the cost on a business. Then automation, the same, AI and automation. They also need to adopt to that, and the existing tools need to be replaced with the new ones. And obviously, the tool A, if it was without AI implemented, and the same tool with an AI implementation when it comes, the amount is going to be tripled. So that cost is also added into the total cost what is happening in the organizations to protect or due to the cyber crimes or protect from the cyber crimes. Again, nowadays, most of the big companies are also there into cyber insurances. So large organization, they also have some insurance created to protect for the financial losses what was occurred by the cyber attacks. So that also a huge amount need to be paid as premium, and that is also added as to the cost what is required to secure an organization from the cyber crimes or cyber attacks. So these are the major reasons why actually it is getting so important in the current day scenario, and why the cost is also increasing. We can also imagine that, okay, the if smartphones an example, smartphones which was available maybe 5 or 6 years back, it's the same, almost a similar one. If you're looking now, it is cost has been increased. So it is not just the company has increased the rate just like that. It's not in that way. It is because the infra what is required to manufacture any such things, and within the device also the computation power need to be increased, the storage need to be increased. All is also because of these different inline things like encryptions and all those things. What is there? That is a need, and for the need, obviously, cost will be getting added. So, cyber cost is also added to the common man. I could say in that way. So yes, so now we try to get into the common cybersecurity threats. What is there actually? As I said, threats are something like which is there everywhere. It is there. Okay. For a simple example is that, okay, you are in a road. So in a road, you obviously have the threats like you can be hit by a car, you can be hit by a cycle, you can be hit by a lorry, even you can be bite by a dog. So you have the threats there. Now, what makes these threats? It is there. You can't escape out of that. Only thing is that, okay, you have to be cautious. You have to be in a safe way, on a safe commuting way, so that you would be safe out of all these cyber threats. Okay, not cyber threats, the threats what is there in a road itself. The similar way, there are multiple threats in the cyber area, which is almost constant actually. Okay, these threats are the same even if you look 10 years before also, the threats are the same, but the way in which these threats are getting operated, that has got changed. So one example would be the phishing attacks. So phishing attacks, the common or very simple one for us to understand is that the SMS or calls that what we are getting these days, like, okay, your bank account is getting frozen due to some KYC non-submission. Click on this link to upload your KYC. The links will be there. They will be also saying that, okay, you have a package which has been sent, and that package was having some illegal items. You connect to customer care to somehow fix the issues and all those things. So all these are actually part of the phishing things. The earlier one, which I said, the SMS one, they also call us smishing camps. They will be calling them in that way. Then the phishing also has something like website spoofing. It is very common. Like, okay, people will create a website which has a same lookalike of an original one, like the banking sites and they will be actually placing all the controls how it was looking earlier. The same look and feel will be there, and people will be by mistake thinking, okay, this is my original one, and they will be actually providing their credentials. Once the credentials are there, then anyone actually can get in. Even previously it was there. It was something called SIM card spoofing. That also was there. I think now that is into to an extent control, but that also was one sort of phishing attack. And another phishing attack is something like to organizations. Normally they will get fake invoices. So it will be like an invoice from a genuine company, but then it would be when you start to go for the payment links or something like that. If in case someone is using the email itself for doing the payment, okay. Normally the companies will have their backend invoicing system, so they will be only processing via the bank transfers and all. But for example, like telephone bill payment or KCB bill payment, whatever it is. So such payments where you'll be receiving an invoice and you will be actually clicking the payment link, then what happens? It will be going somewhere, you will be entering everything. Then after sometimes you will be realizing, okay, my account is also get vanished. So like those attacks, they are, or threats, they are categorized as phishing ones. Very common one these days, even big organizations, what they receive is that CEO fraud, they will call. It is something like you will receive the top management guys. It doesn't comes to the lower associates. It goes only to the top management, saying like, okay, maybe the vice president or somebody says, okay, I am in a trouble, I need some help, I need this much money or whatever it is, they will be sending it. Or sometimes they'll be like, okay, my system has been crashed, this is an urgent one, I need to book something or something like that, I'm not able to do it, could you do that? Like that, it will be sent to his peers actually. Then what happens, they will think these are genuine ones and they will react on them. There are many cases has happened in that way. These are another example of these phishing things. Okay. Then fake tech support calls, like you'll get customer support calls and they will be asking you to provide your OTPs and all those things. Those all are actually fake ones. One common one, even to my family, so my father has received one, was that they said, okay, your account is getting blocked. Please submit your KYC. Click the link. But then somehow his phone was not a smartphone, so he didn't click it. But then he shown to me what I should do with this one. Then I said, okay, it's a spam, don't react on that. We normally look for who is sender, then if it is some numbers, then don't do anything. So these are some basic sanity things that we have to keep in our mind these days. Everything is possible. And yes, we have to secure ourselves. So, as I said, these phishing attacks would be something like that. Multiples are there, just we named a few of them. Then the other one would be a malware attack. So malware, it is like what we have heard about are like viruses, for example, viruses which we had in earlier days. Then worms are there, which is something like, okay, once it is infected in one device, then it could be propagated without any humans trigger. It could be propagated by itself. Then ransomware. We will discuss what is ransomware separately. So these are or some softwares or threads that is normally used to get access to any unauthorized access, like not an authorized person and unauthorized way. If you want to access any systems, then these are the one tool which should be used. Normally, like zip the contents, whatever we receive in our emails, that's for sure it will be having. Then previously it used to be having in Excels, like Excel files, when it is getting transferred, they will have the macros and macros could do something like that. And nowadays, not only these, actually, links earlier, what we have discussed, that one. Then comes to the next type of threats, which is very familiar to everyone, that is a ransomware attacks. So ransomware attacks, it is something like it starts with a malware, basically. I'm thinking that way. It starts with a malware, and that malware has to be somehow got into the organization. So I could quote one example. It would be something like manufacturing plant, for example. The manufacturing plants, normally we know that it is something which is running 24/7, and these manufacturing plants would have the equipments which will be very old. Because why? Because it is running 24/7. Any replacement or something, it is very critical, very crucial, and a lot of downtimes are going to happen. So very seldom people go and upgrade their systems. So even in our organization, if you look now, our plants are also having servers, even systems, which is there in the interfacing things. Those are running on Windows XP. It is still there. And we also accept that, yes, you can use it. Only thing is that we ensure that, okay, those are kept in a secure way. So what normally happens in these cases are like these manufacturing plants, people who comes or operate these systems are actually not the people who are from the IT background. They are not the engineers, basically. We can think in that way. They're the common people. And what normally happens is, using these different social engineering techniques, these people will be identifying one of the people. They will have a tea or they will have drinks with them. They will discuss, ask them about how things are working, how they get into the office, what checks are happening. They will understand all those things. Then they would pretend something like, okay, they are coming into an organization, company like a delivery boy, simple way. He will come. Delivery boys, if it is a vendor, then obviously he has a lot of checks. If it is delivery boy, some manufacturing company, they allow them to get inside. Once they're getting inside, they knows what all things are where, and they easily could bypass things there. So then what they do is uh, somehow they would be able to inject one malware into any system, maybe a USB stick. That is one crucial thing where most of the times these attacks are getting triggered. So what happens is, to an engineer, the supervisor somewhere, this via social engineering, they will be getting in contact with them. They would be actually pretending that, okay, some solutions or something is there which will be useful for them. Maybe it's a private thing. Okay, they will be saying it's a private thing. But these guys, they don't understand what is private, what is to be used within their organization. So they may come and plug these USB sticks into their computers, which I said earlier, it would be very old ones and all, which may not be so protected. And these are connected in the networks also. The entire infrastructure network, with this system is just a system which is connected into that. Where that is malwares will be getting inside. Once that is got inside, then yes, the control of the systems and the things, it will become a gate for the attacker. Then they will start doing it. These are the most things what we see in the movies. The similar way, only it happens. And the other way is that, okay, the phishing way also, as I said, they would be sending some invoice or something like that by a click of the file or something. These malware will be sitting inside to that system, and whenever they want, they could transfer the information, they could opt out. So that's how this malware triggers. And once that is getting triggered, what they will do is that in most of the cases, the ransomware attacks, what they do is that they actually encrypt all the data what is possibly available in, not in that system where it was actually initially gotten. It will be propagated or it will be traversed in the network. It could go into a server like the database server or whatever it is. They will go inside there. They will actually encrypt the old data. They're not stealing anything. They simply encrypt the data. And the encryption key would be actually with the data. And to release the data, they would be asking money from them. And the money will be really very huge because they knows what is a production and what is a revenue it is generating. So they will be bargaining according to that. In some cases, it would be banks or something, they will be simply encrypting their customer data. That way also you can actually harm that particular organization. And that is what these ransomwares are normally do. They demand their money and they will be actually paid off and they will be decrypting the data. And social engineering, it is, as I said, it is a manipulating the person's emotions and all, and they will be trying to get access to those data. Then password attacks. Password attacks, it is very old and new. It is actually attempting to steal using brute force or something like that. You keep on entering different combinations of password and one will be clicked. You'll be thinking. This one, how they are actually doing it is that they also do the social engineering before to that with you, and they will understand what is your way of thinking, way in which you do things and all. Then they would be actually making utilize that one to brute force your passwords. So most of the time, what happens in general, people used to say, if it is a man, then his girlfriend's name would be the password, or date of birth would be the password, or wife date of birth would be the password for kids. So these are the passwords combination normally people do. So once they able to understand what is that, then yes, with that they would be able to attack into that. Then credential spoofing will be there, which is actually something like where actually the certificates and all, we'll discuss that in detail later. But they will be actually stealing your information via which is normally getting encrypted but stored, but they will be stealing that, and with that they will be actually able to get inside. Then man-in-the-middle attack. These normally happens when there are some misconfiguration. I would use the word misconfiguration there. One example is that you have a communication with a system. So from your mobile or whatever medium it is, you have a communication with system. And if that is not an HTTPS enable, then what happens? Your information is actually passed as a raw data. There is no encryption, nothing. It simply passes the same data. and someone is who is actually in middle, who is monitoring the network, the data which is actually transmitted. It has always ones or zeros, which is getting transmitted. They can recognize what it is, and they can actually modify the data. They can steal the data. They can do whatever they want with the data. So that is one of the major one. This is not only limited with these IT systems where the data transfers. This is also possible in systems like cars and all. So what normally they do is that the temperature, what is getting generated from the ECUs or the wires which is transferred, even that can be now calculated. With that also they will identify what type of data is actually getting passed. So to that extent, our technologies has been increased, and they are able to steal the data in the communication channel itself. Then the last one, which is something like the denial of service attack. You might have heard about, okay, Facebook was down, all the Google service was down. So mostly what happens here is that they are not actually deleting the data, or they are not stealing the data. Rather, what they simply do is that they overload the systems, they overload the servers, they overload the interfaces, what act as the like jump host or whatever it is. They will be overloading that with the request and all those things. So with that, what happens is that system would be exhausted from their resources, and it will go down. Once that is, if there is no load balancing and all those concepts not implemented, what happens is that once that is, that entry point is closed, then that particular service will not be available for the people who are requesting for that. That is a very common one, with most of the passing too many requests and making it process a lot of things, and with that ensure, okay, it is done or dead. So these are the major denial of service, and these are the major ones of threats what is available in the cyber world. And almost these are the same, as I said earlier. Even past 5 or 10 years back also, almost the same thing was there. There is no major changes in that. The way in which these threats are getting operated only has changed with the technology. So yeah. So what are the major impacts of these cyber attacks? So as I said earlier, yes, there is a financial losses will be there, like ransomware payment, the legal fines. As I said, the GDPRs of 20 million or 4 million, I think 4% which of the revenue lost generation that need to be there, need to be paid. And that too, it is something like, for example, if an attack happened and they are not informing that such an attack happened to the cert of the country, then also a fine is there. They are supposed to inform the cert of that particular country. For example, if it is in India, then Indian cert IN, they have to inform such an attack has happened. If something like that is not happening in European Union, then what happens is they have to pay within 72 hours, okay, again 72 hours, then the fine is almost around 20 billion euros, just not informing on time. So you can just imagine you already lost with a ransomware. On top of that, you, because of some reason you forgot to, or you delayed the sharing of the information, that also is getting fined. So legal fines are huge actually. Then that is one loss. Then the indirect costs like downtimes, loss of sale, reputations, and all will be major financial losses. Then data breaches. It is, as I said earlier, like GDPR, like European Unions and all. If in case your personal informations are leaked out, that too, if they know it has been leaked out from a particular organization, then the fines are also the same what we have said earlier, like 4% or something like that. They put a common slab there. Fines are almost same. So exposure of the sensitive personal and corporate data, then identification threat and privacy violations. So like once your informations are leaked out, like passwords, if it is leaked out, normally what happens is passwords will be extracted out from any of the system. Then normally it will be sold in the dark web. So in dark web, people are there who are ready to purchase. These are again some organization who do cyber activities again, they purchase these passwords and they will be using it for some brute force attacks somewhere. That's why, as a best practice, people say, okay, you always have to change your password in a minimum time of 6 months to maintain that your passwords are getting changed. Then regulatory penalties, as I said earlier, the HIPAA, it is related to healthcare and all. So any healthcare informations are getting reached, it's hugely fined in US and all. Then yes, the other major impact will be the operational disruption. The example that JLR, what we discussed, it is almost now 15 days, no productions are happening. Then if it is a hospital or something like that. And the best example, which I forgot to say, it is that our in US, because of the Cloudflare, what happened, the CloudStrike. The CloudStrike had some new logic implemented, because of which the entire ticketing systems has been blocked. Then you can imagine how much loss had happened. I think past couple of months back this incident happened. So not only any manufacturing or any organization even can impact systems, even like hospitals, like the patient database, if it is getting lost, then yes, nobody can't do anything. They don't know what medications they were doing, what was his illness, so, yes, everything. Then damage to reputation, if someone knows, okay, you are not capable enough to handle your cyber data or their digital data, then yes, it is going to harm you. So the example which we discussed initially, like the election data, if someone is able to tamper the data, then the trust on that system itself is gone. So nobody will trust that system. And the similar, I think something was there, like if there was an allegation that I think the voting machine, electronic voting machine, it is possible to tamper. Then earlier, when we introduced this thing once after a couple of years, many of the European countries as well as US has actually given orders for this electoral systems. They also wanted to implement something like this in their countries. But then a lot of allegations came, they had gone back from that. Yes, decided no, we don't want to lose our reputation. We want to be whatever, even if it delays it, let it be fine. We will go with that. Then will be legal and regulation consequences. As I said earlier, every organization, for the quality purpose, they will be going through different compliance checks like ISOs and all will be there. And if in case you are getting found out that okay, there is a breach happened or something like that happened in your organization, then the fine imposed on them is also a huge. Then yeah, government cases for sure it would be there. Then national security threats. As you know, this Ukraine-Russia war, it was the initial days. What happened? The Russian hackers, what they did was they actually hacked into the Ukraine's entire power grid, and they shut down everything. So you can just imagine, once the power is not there, what is going to happen. So like that, even different nations are actually promoting cyber attacks. They are making it as an industry. They are doing it as part of an industry. For a government, they got a project, they are doing it. Even in India, if you look in, we also do cyber attacks, or we do cyber crimes, I could say in that way, hackings and everything we do into the neighboring countries' networks, communications, everything. So that is justified by, okay, it is on the national interest, national safety, everything they are doing it. So anything like that happens, then yes, it is on the security threat on that particular country, right? So similarly, national security is also a major one. As you know, these days everything is digitalized. If in case, if like the power grid example, if your other server, if it is not available for some time, you can just imagine what all things are going to break now. So even buying the ration from that time, food downwards to even your election, to that end, it is going to tamper. So that is the national security level threats we can imagine. Then yes, psychological and social impacts. this data breaches, whatever happens to any of the personal devices, and if your personal private data are getting lost, then you can just imagine how much stress and how much emotional psychological impact is going to happen. So these are the major impacts that we can imagine due to the cyber attacks. Then let me get into the cyber vulnerabilities actually. So till now we discussed what are threat actors. Threat actors is, as I said, it is there from the beginning, it is there, it will continue. Only thing is one or two additions will come and the methodologies will change. But this technical vulnerabilities, whatever we are going to look in, these are something like which is getting induced by each one of us. So for an example is like an unpatched software, an outdated component or something like that. As I said earlier, in a manufacturing plant, you will still find an Windows XP system there, but then it is not getting patched. But if you are just like that, allowed that system to connect into the network, then yes, it is a major security flaw. It is a vulnerability. But then you can actually mitigate that. What they do is that the whole technical term is just segregate their network. So what they do is that they will actually bring in firewalls in between, and through the communication only happens through firewalls, or they would be having different nodes in between, so that from one direct connection doesn't happen into the network. So it will be checked in between. So like that, you can mitigate it. So one of the major one is actually this unpatched one. The common one, what we could be getting targeted as Indians is that most of us, we will be still using the pirated versions of Windows XP or not Windows XP and Windows operating system. And the one word what the vendor would be saying to us, this is a pirated one, or it is it's like, okay, you should not update it or connect to your Windows servers, this thing, the security updates and whatever happens now, you don't do that. Because it will be recognizing, okay, this is a pirated thing, and they will be actually warning you, they will be finding you, whatever it is. So what we do, we refrain from updating our security patches. Even sometimes we also doesn't update our browsers. So in fact, what happens is all these different browsers or whatever the old version, they are exposed to a lot of vulnerabilities due to their misconfigurations, coding issues, or whatever it is. We are then connected to the same network, internet, what is there. And the threat actors, what they normally do is that they are monitoring each of the network, and they find out what is happening in each one. And if they find out one loophole, they try to exploit it. And if it is individuals, then they will be not only stealing your data. What normally happens, the major threat because of that is that they will be actually using your machine as another system through which they are attacking. So actually they do all their attacks in the network via your PC. You will not be aware of it. You will be simply connected to the network, you will be using it, but meanwhile they would be doing all sort of attacks from your PC, from your IP. So at the end, it is that, okay, you made that attack. So like that, also people would be utilizing or exploiting your system. So always try to ensure that, okay, you keep your systems up to date. All the softwares which are actually connected to the networks, ensure you make them up to date, you patch them properly. Then would be something like security misconfigurations. This is one of the major threat or vulnerability due to which the threats are getting exploited. So one best example would be like default credentials. So many of times what happens, the databases and passwords, whatever we have, we put admin as the default password. We use that. Or admin with password as the common one. These are the common passwords, and the common password database is freely available. Anyone can actually utilize it, and they can actually perform a indefinite run using that and do a cross matching. So any default password usages by anyone, or easy password, guessable password usages, that is one major technical misconfiguration that could happen, especially on major devices or database sort of systems. Then exposed cloud storages. So as we know, we discussed like, okay, most of our data are stored in the network, in the cloud. Like for example, Amazon and all is S3 bucket is where actually your data are getting stored. So even if a port which is actually open on the network and you misconfigure the firewall in the port, it could actually make you to access to that particular data, whatever stored in that. They can steal the data, they can manipulate, they can do whatever they want with the data. So we always think that a firewall is the one which is actually protecting us from everything, but even the base misconfiguration inside the port of a network, port of a firewall itself will cause the damage there. Then another one would be like, okay, you will have a lot of features which is there. Unnecessary features also will design there. Unnecessary data will be actually expressed, like for example, APIs. In an API, if someone is asking what is your name, then it is like it will answer my name is this, I am from here, my job is this, that, and everything. Whatever data is not required, that also will be passed along with the initial simple question. So that is like unnecessary features which is getting enabled, or unnecessary data is which is getting passed out. Then accessing this publicly accessible admin interfaces. That is another a good example. Like many of these admin interfaces would be there. Normally, it should be accessible only to limited users, but then that will be accessible to everyone. It's a misconfiguration by the way, but still that happened. Then another one would be like, okay, any protocols like we discussed earlier, that HTTP is still getting used, where HTTPS is a more considered to be secure, but not most secure, but considered to be secure. But still, we are using HTTP instead of that for the communications. So that is also a misconfiguration. These all are in a server. If you go in, it is just a checkbox selection. If you missed out a checkbox selection, then that's it. It is gone. So that's how the misconfigurations can affect. Then the weak authentication, like what we said, okay, we used common guessable passwords and all, and lacking multi-factor authentications. I hope you are aware of what is multi-factor authentication or 2FA. So it is nothing but just not allowing you to enter using a password. In between, it will ask for an OTP, or it could ask for something like an authenticator app to authenticate. So like Google and all, these days, the Google, it will be asking for a multi-factor authentication. It will say that, okay, okay, fine, you are the right person, you give me the right credentials, but still I want to ensure that you are the right person for that. So what are the different means? Maybe in your phone or something, open a Google app and then authenticate that, okay, it's you. Like that, multi-factor authentications would be there. It is mandatory now. Any application which is handling sensitive user informations like passwords and all, they have to implement MFA. That is a mandatory one. And in organizations, they would go one step ahead. What they do is that they will bring in authenticator sort of apps. Like you might be familiar with this Microsoft Authenticator or Google Authenticator and all. It is make mandatory that, okay, you have to have that authentication there. People who are using Facebooks, they will be also aware that, okay, the Facebooks also, they have mandatorily said that, okay, you should have either of these authenticated to authenticate that, okay, you are the right person. Your authorization is going to happen with that. So like that, multi-factor authentications, if it is missing, then obviously, yes, it is going to happen. Then other one is a basic authentications, where actually what happens is an application you designed, you bring in your authentication there, username, password, that you have brought it. But then what would happen is the brute force attacks can happen on those applications. So someone can use these guessable passwords or commonly used password things, and they will be keep on trying your password multiple times. And if you are misconfigured that one in a way that you allow it, then there is a chance that, okay, your application either can go for a DDoS, means the system will be crashed due to some, or what happens, it will be some point of time, it will be able to guess the password, they allow you to. Then how to avoid such things? They should have actually done at least a captcha checks or a limit check. They will be commonly saying, okay, if your wrong password is entered, allow only 3 times or 3 attempts or 5 attempts. These are the common things which it's mandatory now. Any application which is there, they have to follow these things. Then injection flows would be another good example. Injection flows are something like it's like you have an application. Obviously, for every application, you will have a database behind it, but then you missed to implement something like prepared statements in Java, for example. So if you are directly allowing to, you are written in a way like, okay, you have the query script and the query statement inside a normal string, and you just use that, okay, and an operator, and with that you will be placeholders, and then with that you will be getting the credential from the text box, you execute the query. If you do something like that, what happens is that they could pass anything as the username or password, any field. For example, it is like select star is the one thing normally we put, because we assume that, okay, only one record will come up. From there, the variable will pick. They will put select star from something like that, and the placeholder would be given there. But and what happens here, the end user, what will do, he can actually provide something like a any database. If it is Oracle or something like that, if you use @ or something like that, then normally it will fail. And what happens, it will either show you the complete information about the error. The error handling is not done properly. It will give you the complete information about the databases, and the server names and everything would be given out. So somebody gets that information, he will be able to penetrate into that particular system in another channel. Or sometimes what happens, you would be actually given like 1 equal to 1 in a where clause. If you give, or 1 equal to 1 is sufficient, it will actually bring up all the data. And if it is not handled properly, then it will be exposed also. So injection flows, like SQL injection is one example which I got in. Then is cross-site scripting. So this is something like mostly happens with JavaScripts and all, where the malicious scripts will be injected into a web page, and normally it will be affecting. I could say it is little bit harmless in a way, where actually your cookies will be stolen and the cookies are not managed properly. Then obviously data will be leaked out. So session cookies are mostly getting affected because of that. Then weak encryption, what we discussed earlier. Someone is still using a 16-bit or 8-bit of encryption algorithm for encrypting data, then it is easily decrypted in between. Then insecure APIs. As I said earlier, one, it may not have authenticated properly. So for example, in earlier days, if you remember this Google Map and all, that APIs was accessible to everyone. Or other example would be like the share market data from the different vendors. They all are actually having APIs without any authentications. You don't need to provide any authentication. They normally used to give it earlier, but then they realized, okay, it could end up in a denial of service or something like that. Then now they have brought in, okay, it is authenticated APIs only is allowed. So you, even though it is not paid or something, you but still need an authentication. So you ensure, okay, right person and limited resources are getting shared. And obviously that select star sort of things, if it is used, then somewhere in the API code, they would have to restrict what information is supposed to provide. If it is only to get the name, provide only the name. If you are exposing more than that, then that is also something like a insecure API. So these are some technical vulnerabilities, what commonly happens in the industry, and something which are not technical, it is more towards human centric or design level vulnerabilities. So we discussed earlier, like the phishing and social engineering attacks, those ones. Insider threats, if an employee is not happy with the employer, obviously he can leak out the information. He can also keep open some door back gates. They will open up some back gates, and through that later point of time they will be able to get inside. So they will be keeping the code itself, they will be making it little vulnerable, and they will be releasing if it is not reviewed properly. Yes, it is there, and anytime they can actually come in. Then excessive user privileges. So a admin user is a supermost user in a system. Then if a normal user is able to elevate himself to that particular level, then yes, it is something like a weakness again, I will say it is a flaw in that system where actually we miss the configuration that the user, the admin user's credentials or admin user could not be impersonated by a normal user. Or a user, he has granted normal user itself, he has granted access to every data inside the thing. So that is also excessive user privileges. Then insecure design, while the designing phase itself. One best example will be like you are designing an application, you have access to different data, but then you miss to bring in a load balancer or a firewall systems into that whole architecture, then yes, that itself will be a failure. Then poor data validations. So this is one example, which is a good cause for the SQL injections and all, where actually what happens is there is a text box. Maybe it is for entering a password. Just take an example. This is to enter a password. Then what happens? Normally, we would be restricting, okay, password could be either numeric or alphanumeric or something like that. Restrict to maximum 12, 13, 15, some limits. Sometimes we miss to do that. We'll enter everything. Then what happens? Whatever information it's possible, even a select query can be written there. Then what happens? It goes and it could execute as an inline code. This whatever inputs are coming from the user, that if it is not validated properly in the front end or in the back end, then obviously these validation errors, and due to that whatever harms it could occur. Then lack of access controls. So each user, they will have something like authorization and authentication. So authentication is something which we handle with the username passwords. So username password, which will bring you the identity. Who are you? Like that, it brings the identity. But then authorization is something like what you are inside that. So for an example, a banking website, there is a customer login would be there, a bank employee login will be there, and inside the bank employee itself, there could be someone who is a manager, who will be a normal clerk. So if this authorization, like a customer comes in, the customer has limited access to what they can see there. Same customer data, if a bank employee, if it is he will be able to see few more things what is stored behind it. And if it is a manager, he will be having more. If these access controls are not done in a proper way, then what happens? Even a customer could log in and he could see whatever information of maybe on other user also. I could see some others information. Like Google Drive. If normally we will share like the example of whatever we have now, it is shared to everyone. It is not limited to those people. If it is not limited to those people, then whatever information we have stored there, anyone else also will be able to access it. So normally we will be authenticating as well as authentication anyway with the Google account, but then authorizing whether this person is allowed to access my space. This is part of the list of people who is supposed to access. So like that, authorizations, if it is not done, then it is also a design level vulnerability. Then yes, how normally these vulnerabilities are getting exploited. So first thing what happens is, as I said, people would be actually monitoring what all traffic happens inside the network. There are many tools available. Like for example, one would be Suite. There is a tool which can be deployed. It can be monitored in the network traffic, what happens there. And whenever from a particular IP, a communication goes, and they would be actually assessing that particular IP, the port again. And if they find, it can be easily found out also. Like in our browser, what all are the, if you're opening an application, we can easily find out what all are the different like libraries which is getting used. JavaScript, if it is there, then which version of the library is getting used? What are the different libraries which are getting used? What are the different third-party packages which is used to build that particular application? This is actually listed there. And if they find out a particular, maybe for example, Node.js or something, a version which is actually vulnerable to some of the vulnerabilities which is officially available. Normally these vulnerabilities, like any software vendor, they are supposed to publish all the vulnerabilities, what is there with the remediation. They normally will be actually publishing these vulnerabilities. They call as CVs and all those things will be there. So you can actually find out those things from the CV, the what we say, security advisories. They call them in that way. Any product, any software, what is available, they also will have a security advisory part where they will be actually publishing what are the vulnerabilities affecting my software and what are the remediations for that, how they can be get fixed. And if in case there are something called zero-day attacks, where it's something like, okay, an attack happened, the same attacks, whatever we discussed, no, same thing is the zero-day attacks, but only thing is that there is no patch available, there is no fix available. So only solution is time shut it down, limit the access to externals. So this is a way which they identify the vulnerability or identify a software which is vulnerable. So that is the first step what they will be doing. Then what they do is that actually they develop different exploits. So like Mintrail, like that, frameworks are there where which will be actually showing, it is showing you like, okay, this particular vulnerability, if it is there, then these are the different steps by which you can exploit that vulnerability. These steps, it is actually publicly available, and most of the people utilize that. Why it is publicly available is that as a developer, as a software developer, you should be aware what all are these vulnerabilities and how this can be exploited so that you could bring the fix upfront itself. But the other hand, they will be actually developing the use cases for this exploit. So they do these different things and actually they try to attack that with that particular whatever weakness it is found out, they try to attack it. Then they will be actually started to deliver this one. Now you define the software, everything, right? Now need to be delivered. If it is a web application where the vulnerability is existing, they can actually make use of the tool itself and they can gain the access. Actually, they can get inside the port, and if it is a weak authentication, they crack the username password, they are able to get inside, they can do that. Like the manufacturing plants and all, that is not possible. It need to be brought into the network thing. For that, you need some way of delivering it. So at that time, they will be using the phishing, or they will be directly, somehow, as I said earlier, they will be impersonating as somebody else and they'll be getting. It's possible in a huge manufacturing plant. These all are possible, and they'll be doing that. They'll be delivering that exploit where they would like to deliver it. Then once that is done, then they will be getting the access. So if it is a network, that internet way, the application wise, then what they do is that they will identify a server. From that server, they try to access that server from the online. And if that server is accessible in that particular port, on database ports and all, they are with the SQL injection, they will be able to identify what was a port, or what the server name, IPs, and the ports through which the connections are exposed. Then they will be actually trying to access that one. In case there is a open access is available, then they will be getting in, then they can easily steal out the data. Even encrypted or not, data are getting stealed out. If it is secure in a very good way, but they left the gate open, then obviously they will encrypt top of that and they will make for the ransomwares and all. So this is the way in general what these exploits happen. So you have to be very cautious about the vulnerabilities, what can be there in your systems. It's not only on the development phase, even when it is on the operation phase, when it is a live system, then we have to periodically check what are the different dependencies. We call the softwares or the dependency third parties, whatever we are using. You should have we call them as a bill of materials, software bill of materials. So what are the different softwares or the libraries or the third-party dependencies through which we are utilized to build this particular application? Then that one should be listed, and someone has to be periodically monitoring what are the different vulnerabilities reported out of it, and what are the patches, and are we doing the patches on time. So these are some methods, but normally it has to be done there. So these are the ways in which they would be actually exploit really happens. So threats are there, the vulnerabilities are, if it is there and if it is exploitable, then only the threats are dangerous for us. Otherwise, threats will be always there. You can live with the threats. So some past exploitations, I think you might be heard about this Log4j vulnerability, and where it was a remote attack. What really happened? It was Log4j was a logging library, Java library, where what they did was they actually inside that they do a remote code execution. Means they somehow put in some code which can be get executed. They passed it through the library, and through that they were actually able to exploit and injected malicious codes in this. And the impact was like full control over the affected system, major companies, cloud providers, everything was getting affected because of that. Then WannaCry ransomware attack. Then what happened was it was a unpatched Windows SMB version 1 protocol. SMB1 protocol is actually SMB is a server message block. It is the expansion. It is a communication protocol basically. Normally it is used to communicate or interact between the devices like printers, scanners, and all those things. It will interact with that. But that protocol, the problem was it is not encrypted. And it was actually deprecated in 2014, but until 2017, people were using it. And somewhere in 2017, this particular attack had happened, and it has affected a lot of things, and it has actually literally disrupted everything. Then phishing and credential thefts. One major one was through the employee who was unaware of this phishing tactics, and he logged in with his credentials into a fake account. So they were able to access the emails and cloud storage of the internal systems. Then in 2016, another one was Equifax data breach, where attackers, whom it is, they are not aware of it, but unpatched Apache Struts web application framework was the root cause for that particular attack. And again, a remote code execution was done with it. And again, the patching was missed. It was like, again, 137 million personal information was stolen there. Then mobile app data leakage. These app scanning these public APIs, they identified, okay, some poorly configured Firebase database was using a mobile app. Then no authentication was required. They were able to access the sensitive information. So exposure of the personal information. That was a major flaw there. So again, who developed the app, they will be scrutinized for any such of activities. Then is what are the prevention tips? I think we'll 4 more minutes left, so we'll look in. So what are the prevention tips there? It is like, okay, regularly patch, monitor, and patch it. So you always maintain your inventory, ready, whatever things are used, regularly patch them, and ensure that, okay, it is not vulnerable now, or at least you are mitigated vulnerabilities, what is available. Then periodically conduct a vulnerability test assessment. So normally the vulnerability assessment includes a pen test and all, where actually you are literally doing a hacking into the system. So you test that one with the different this military attack frameworks and you'll utilize it. Then check whether the vulnerabilities are getting, is there something like that? If it is there, then periodically fix that. Then implement a proper network monitoring and intrusion detection. Then final thing is educate your users regarding the threats. Because even if you do whatever it is there, but if your person, if he is not properly doing his work, then obviously, yes, a social engineering attack can happen, and that he will be the key to enter into all the secure systems also. So human is always the weakest link in a cyber world. Then the guardrails, what normally anyone has to follow is that, okay, keep your system up to date, use strong authentications, wherever possible, implement the MFA, then regular security trainings, educate the people what is required, what is not to do, then implement a proper security, network security controls like firewalls and intrusion detection and all, then perform vulnerability assessments and penetration tests on a periodic fashion. Regularly back up your data so that in case of any sort of ransomware sort of attacks, you still can dump those resources and build in a new if you have a proper backup system. Develop a incident response plan. So it is again required because if you fail to report even a vulnerability, then yes, you are into trouble because of the illegal things. Then enforce access control. So always have a proper role-based access control system available, and always authenticate or authorize users using that access control systems. I think the protection methodologies, and I think, yeah, 1 moment, so I will make it fast. Firewalls, as we discussed earlier, it will be always the barrier or which will stand in between you and the network always, so it will be helpful to protect unless it is not misconfigured. Then antivirus and anti-malware. So always ensure that you have a proper antivirus even your mobiles and your PCs. If it is used for browsing, it should be there. Then intrusion detection systems. Mostly this is required for organizations. Then encryption tools. You should always have a encrypted communication. Then for multi-factor authentication possible, then it should have that. And only use such systems. Don't use any system where it doesn't have any sort of multi-factor authentications, because we use a common password for everything, right? So that's why. Then have a SIM system, which is actually looking into the events and monitoring the events and giving you alerts. Then endpoint protections. Then VPNs. Organization mostly use a VPNs for remote connection. So we can also looking into that if you are connecting to any unsecure systems. Then proper patch management and backing up solutions. I think I'm done with my time, but if you have any questions, please. Hope I was clear with my presentation.
Participants now can ask questions. Either you can unmute your mic and ask questions, or you can post your questions in the chat box. You can utilize this time. I think that means there are no questions.
Yeah, if there is no more questions, then my last slide. Thank you for your participation.
Thank you so much, sir. Thank you so much. Participants, the feedback form is now available in the chat box. Kindly fill the feedback form so that you will make sure your attendance, and the feedback will be also entered. And now I would like to express our gratitude to Mr. Suresh Kumar sir. Sir, I wholeheartedly thank you for your information and eye-opening session on cyber threats and vulnerabilities. Your guidance has made us more aware of the challenges in the digital world and the importance of safeguarding ourselves. Thank you so much, sir, for imparting such practical and timely knowledge. I thank all the participants for their active involvement. Once again, thank you so much, sir.
Thanks for the opportunity.
Thank you, Suresh. Thank you for being with us today.
Thank you, ma'am.
Thank you.
So let's move on to the next session of the day on the topic AI and data science with NIME, a no or low code open source platform. Let me introduce the speaker of the session, Dr. Melvi Metipara. Dr. Melvi Medipara is a senior data scientist at Kaiser Permanente, the premier integrated healthcare management organization in the USA. With over a decade of expertise in advanced analytics, machine learning, and natural language processing, Melvi continues to be instrumental in delivering actionable insight in his team. At Kaiser Permanente, Melvi has spearheaded numerous strategic data initiatives and enterprise-wide decision support projects. His work includes developing predictive models, automating data pipelines, analyzing member journeys, and creating NLP-driven dashboards. His efforts have fostered cross-functional collaboration, enabling him to present results to both technical teams and senior leadership. Through rigorous analysis, Melvi has identified opportunities for cost savings, and service improvements. Beyond his technical contributions, Milby is committed to upskilling teams and promoting the adoption of innovative analytic methods among colleagues. He holds a PhD in life science and has several years of research experience at UCLA VA Medical Center. He conducted pioneering research on sleep mechanisms and neurodegenerative disorders, publishing 15 peer-reviewed articles and contributing to NIH grant proposals. Milby holds a spectrum of certifications from leading institutions. He has been a featured presenter at the Kaiser Permanente Annual Innovator Conference and was an invited speaker at the NIME Summit 2018. Sir, it's a great pleasure to have a person like you with us today. We wholeheartedly welcome you, sir. Over to you.
Thank
Sir?
you.
Yes,
Yeah.
okay. Sir.
Can you all hear me?
Yes, sir, it's audible now.
Thank you. Thank you. Thank you for that great introduction. Let me start sharing the screen. Good evening, everyone. It is good morning here. It's actually 7:05 in California now. I will start sharing the screen. Okay, just 1 second. Right. Okay.
Yes, sir.
Thank you all. So today we will be talking about NIME, a no-code or low-code analytics platform for data science or AI. We'll be covering somewhat quite a bit of ground, you could say, but again, it's kind of a whirlwind tour of NIME in some sense. So we will be talking about an overview of NIME. That will be what is NIME, why use NIME in the first place, and then who else is using NIME in the industry across the globe. We'll be talking about some of these core concepts in NIME and also go through the interface of NIME, the core concepts, and then we'll be looking at some of these data pre-processing steps and the transformation steps, which are essential if you want to do any AI or data science, because that is, you cannot help it. There is one estimate, apparently 70% of the data science work is actually data cleaning up, data processing, and then followed by a tour of the machine learning AI capabilities of NIME. We'll be talking about feature engineering, different types of models. How do you evaluate a model, interpret the models, and also how do you do it kind of quickly using a method called AutoML, and also some of these more recent methods like deep learning, and also explaining the models using something called XAI or explainable AI, and briefly touching upon the NLP and also the newer kids in the block, somewhat newer, you could say, large language models and the generative AI, and also how the different external extensions are integrated into NIME. And then we will briefly touch upon the data visualization, because a picture is worth 1,000 words. A lot of the modeling will not mean much to the business stakeholder if it is not properly visualized. So we will just briefly touch upon that. And finally, we will conclude it with a value proposition for the data science and AI, for what is the value proposition of NIME in this data science and AI, and how valuable it can be for the data science education for an academic. And I will also share some of the resources and some of the next steps that the audience could take. All right. So what is NIME? NIME is, it's actually a short form for Constance Information Miner. It is named after the university where the founder of this particular product was based as a professor of bioinformatics and also computer science. His name is Dr. Michael Berthold. I think he started working on NIME sometime in 2006 or 2007. So he collaborated with several people from actually he was probably he started working on it while he was visiting San Jose, Silicon Valley, and he wanted to have a product, a software which would be open and which would be free and which would also have a lot of capabilities packed into one. It will not be a toy software, but it is also accessible to everyone who doesn't also know any kind of a programming. Okay, meaning any kind of coding. That's what I mean. So this is a free, open source, and a visual design. That is the important thing. The visual design. When NIME started, that was kind of pretty unique at that time. Now there are so many other tools which are kind of mimicking the capabilities of NIME, but still NIME is a good value proposition because it is free and it is also open source. Continuous developments are being made um, in this particular platform, and anyone can contribute it. Um, Free in the sense, okay, some parts of it, if you want to have a server, then you had to pay for it. But you can even kind of bypass that if you can automate some of this kind of workflows um, in your own system. That is possible. In our team, we have been using it that way recently, actually. I have been working with NIME off and on. I don't know how long, but again, not a very regular user. Recently, I started using NIME a bit more often. So I will be looking at, while I'm doing this presentation, I will be um, looking at mostly the legacy user interface. Towards the end of this presentation, we will also look at the modern interface, which is much more sleek and probably much more friendly for a beginning user or who has never used NIME before. The reason for doing that is a lot of the workflows I have open, they are in the legacy workflow now, sorry, in the legacy user interface. And if I change it to the modern interface, like I had to close it and restart everything. So one main advantage of NIME is it completely demystifies machine learning to a certain extent, meaning like you don't have to climb the additional mountain of knowing the coding, right? Because this is the no code platform. So this is especially useful for the beginners where you can blend the theoretical knowledge with the practical tools. And let's look at who is using NIME. One of the early users of NIME was in the life science industry, particularly biotech and pharmaceuticals. So that's why life sciences industry, including as in pharmaceuticals and biotech, they have been heavy users, and because of that, NIME has several extensions, which is particularly useful for that kind of field. Meaning, if you it is very useful for things like if you want to investigate several candidate drug molecules to look up which of the drugs would be a potential candidate, which of the molecules would be a potential drug candidate. Right? So and we are talking about companies like big companies like Novartis, Pfizer. So we are talking about this kind of big hitters. It's not a toy product. That's the whole point. And then it is used in healthcare and marketing analytics. That's where I have been using it. The Kaiser Permanente is a integrated managed healthcare, and I'm working in the general division of the marketing, you could say. It's actually the insurance side of it. So there we have been using it NIME, and then it is also used for some kind of compliance or the fraud detection. So that's where the internal and the external audit is. The screenshots, what you see here, it is the different types of industries which are actually using NIME across the globe. So like I said, life sciences, insurance, healthcare, then telecom. Telecom is a big time user, and the energy sector, the travel and transportation, all of them are using NIME. When we go to this NIME summit or the conference, a lot of these users are actually European users. In the last probably 8 to 10 years or so, US also has several several users of NIME. And I think like India also has several users. When I was looking at this pattern of the profile of the users, and the several departments within those industries are using it. Recently, data science, um, then research and development. It's a big, it's really big with them, and supply chain, marketing, like we do in our department. And then some of the use cases are, like I said before, this is for the diagnostics and the drug discovery, for getting insights from the customers, like which customer is valuable, which customer may churn or may leave the company, um, or fraud and risk management, supply chain analytics, or automating this process. So that would be something called the process automation. Um, and even in the HR. So these are the some kind of snapshots of the use cases where NIME is useful. Now we will look at the core concepts and the interface, how NIME looks like, right? So first, let's go to the core concepts. So like I said, this is a low code, no code platform. It's primarily a no code platform. You don't have to do any coding, but if you want to do the coding, there are scripts, there are some of the nodes where you could um, do the scripting in Python or Java. Okay, so these are the three different types of coding that is allowed in NIME. In fact, NIME is actually built on the Eclipse platform. That's so it is actually built in Java. Now, in the last probably 2 years or so, they have ported a lot of the coding to Python. So you could essentially build some of these nodes in Python. Previously, you had to do in Java. But I'm not talking about the building some particular functionality. I'm talking about building some scripting. Okay, so the core concept is if you have played with the Lego, right? Like say it's the toys game. Like say if you want to build for example, a dinosaur, you build some of this kind of small squares or small blocks, and then attach them together. That is how it works here. There are multiple nodes. Each of the smallest entity, that's called a node, and each node has a particular function. It can be for pulling in the data, for processing the data in some particular way. For example, you want to select a particular column or filter out some of the rows, or maybe build one particular model or apply that model. So each one of this functionality, it is encapsulated into one particular node. And when the nodes are stringed together, that forms a workflow or a pipeline. The screenshot what you see here, that is it's not very clean, but anyway, like we will actually be going through the interface, so it will be much more clear. The another core concept of NIME, as I mentioned before, this is completely open source, and because it is open source, it is also leveraging the strengths of the other open source components in the entire open source ecosystem. We are talking about it can pull in a lot of the functionalities of the other open source packages. Like say, for example, R. R is in a sense kind of integrated, not really integrated. A lot of the R functionality can be pulled from here, and so is other kind of open source initiatives. Like there was an open source initiative by University of Waikato in New Zealand, probably 15 years ago. That is called WECA. That is Waikato Environment for Knowledge Analysis. And WECA was the leading package of its time at that time. I'm talking about probably maybe even more than 15 years ago. All that functionality is wrapped in here. But see, at that time, open source was not really a big thing. But now everything is open source. Like all the big companies are developing in open source. They are contributing to the open source world. So that is why NIME is a really good value proposition now, because this is one engine which kind of siphons all that open source strength into its platform, in addition to whatever is unique to NIME, right? So that is a core concept about the NIME. Now let's go into Okay, let's go into the interface. So there are what you are seeing here is a legacy. It's a screenshot of the legacy interface. Um, Instead of talking about this one, why don't we go there? Just 1 second. All right. So this is how NIME looks like. So let me open a blank page so it wouldn't be so overwhelming. All right. Okay, so this blank page, so that is the workflow editor. That's where you bring in all the nodes, connect them together to form a workflow or the pipeline. And the one on the left side, that is called the NIME Explorer. Oh, by the way, this is that legacy interface. If you click here, it will open the modern user interface. I don't want to do it now because this can close all these other open workflows, and which will force me to restart it. Okay. The one on the left side, what you see is that is where all the workflows are stored, and it can be either local in this computer, or it can also be in the NIME's forum or the community space. So there are two parts, which is freely available to everyone who signs up for NIME. Or it can be even the community space. Either it is personal or it is community. So personal is whatever you post into your own personal space that is visible only for you, unless you want to share it. And then local is your local machine, of course. And this was a neat feature some time ago, but now it is not particularly that neat anymore. It's more like, say, if somebody is totally new to NIME, and if they want to build a workflow, suppose they put in one particular node for file input. Okay, what would be the next best node to be used? What is the next best um, node used by the community? So this is more like a community ranking of which particular node is used after what. Okay, so um, you don't even have to bother about this one. This was kind of a this is the legacy feature, and probably it is not really that valuable anymore. But this is where the majority of the action is, the node repository. That is where a lot of this functionality is encapsulated as this kind of tiny entities. Like it can be for reading or writing the files. If it is reading, like these are the different types of files that you could read. Again, this we are only talking. We will talk about what type of data acquisition is possible here. So essentially, these are the different classes of the nodes. Okay, and then if you build a workflow, and if the workflow is too large to fit in this particular screen, the outline, it is kind of a thumbnail where you could move around. And this what is the console? So that shows the, because I had executed some of the workflows before, so that's why you see this kind of messages. And the node monitor, it is showing the output of the currently selected node, right? And on the right side, you see there are two tabs. One is if you select, right now it is a blank, so that's why you don't see anything. But if you do select either here in the node repository, say for example, you want to connect to a database, for example, maybe we use quite a bit of SQL Server. So then it will talk about how do you use that connection. Okay, it is actually kind of a user guide on how to use this particular node. And then NIME Hub, which is enormously valuable. Okay, so this is where they host all these free workflows are as examples, and other kind of functionalities, and also a lot of these extensions, which actually make the NIME a real powerhouse. Okay, I will actually demonstrate some of it. Like you could, if you go here, you could actually, there is a starter collection, which is some of the kind of beginner-friendly examples of the workflows and how to use it. It is not just the beginner-friendly, like you will also see a lot of these advanced workflows, right? Now, so that's about the user interface. And now let's go to, okay, what was it? One specific example. All right. So one of the things is like the NIME can, the NIME nodes, this is an example workflow where it is actually reading a list of the Excel files in a particular folder, and it is reading all the Excel files in that particular folder. So what you see, each one of them is a node. So this is several nodes wrapped together. That would be called a meta node. Actually, we will talk about that in the next slides. I think I'm probably jumping a little bit ahead. So why I'm showing this one, see, what you see is that kind of a green dot at the bottom, right? Probably it is easier to show the comparison. What was that? Yeah, see here. This is ending in green, so meaning this workflow has successfully executed. And this one is showing yellow in the middle. So that is, it's more like imagine more like a traffic light traffic signal, right? So the green is completely successfully executed. Yellow is correctly configured but waiting for execution, and the red, that is not configured. Okay, so that is the two different states of the node. We will be actually going through this workflow later. Now, now look at we will look at the core data handling and the data manipulation in NIME. So without, as in, if you want to do any AI data, the primary ingredient is the data. Without data, you can't do anything. So that's why, like for some of this kind of modern LLMs, since there is not much of a data, they are even creating the synthetic data. So these are the different types of data acquisition possible in NIME. It can be through the files. So it can be in any of these formats like CSV, Excel, JSON, XML, Parquet. Then it can be the remote file system. We are talking about this Amazon Web Services, Azure, that is a Microsoft, or the GCP, Google Cloud Platform, or even Hadoop distributed file system, which is kind of older now. And it can also connect it to both the traditional databases and also the non-traditional databases. Non-traditional in the sense, non-relational databases. So relational databases like MySQL, Postgre, MySQL Server, Oracle, those kind of things. It can also connect it to through the special connections through other databases like the Neo4j, which is a graph database, or MongoDB. So that's why I'm saying like the non-relational databases. And it can also connect it to outside APIs, things like the Google Analytics or Google Sheet or the Google Drive or the BigQuery. So these are some of these examples. It is not only whatever is listed here. I'm just giving a snapshot, right? Now we will look into the data pre-processing and transformation. Even though AI is, or the machine learning is the meat of this talk, without processing the data, like I said, 70 to 80% of the data scientist's job is actually processing the data ready for modeling. Hello? I heard some noise. Anyway, that's fine. So these are the different types of data processing possible. Again, just a snapshot. The column operations can be like the filtering a column, selecting or removing the column, renaming the column, or combining different types of columns. Our operations can be filtering out a row, splitting a row, sorting a row, or if you have any of the missing values, it can handle the missing values, or partition the rows so that it be primarily be useful when you are building a machine learning model. Splitting the data into training or the test set. So that is a raw operations. And then aggregation, the pivoting, which is really important if you want to kind of summarize the data in some sense. For a lot of these workflows, it is integral. Especially, okay, so for that, there are possibly the most, how do you say, not just the universal, the most powerful of the nodes in NIME, it's something called a group by. That is where you do a lot of different types of aggregation and also pivoting the data. Then there is this kind of expression language, which is actually embedded into multiple nodes. The expression language of NIME is kind of somewhat weird. Actually, I will show you some of that. But you don't even have to kind of type it, because you had to just drag and drop it mostly. So that will create that expression language. It's more like, say, if you want to create some kind of an if-else kind of statements. What else? Or some kind of a rule-based behaviors. Yeah. So that is when you actually use that one, and it is actually integrated into several nodes like column expressions or the role engine nodes. Then it can handle a variety of data types. It can be float, boolean, datetime. Essentially, there is no limit, really. Okay, and also special types of data that can be path, a file path, or a file collection, or it can even be some kind of a document that's actually a data. And the image is a data, blob is a data. So that's why I'm saying, like, there is no limit really. And then lastly, a lot of the in recent, not in recent times, like a lot of the data scientist work will involve handling huge amounts of data. So one of the bottlenecks in this process is moving the data around, right? So that's why it is always better to keep the data where it is, that is the database, and also bring the analytics to the database. So that is why NIME also has several nodes for the in-database processing. So let's go into, okay, let's go into that. Just 1 second. Actually, I don't know if I could, yeah, I don't think I will have any examples here for the in-DB database nodes, but okay, so let's, you know what, probably it is much easier here. Yeah, database connection. These are the different types of databases, and we had seen that one here, read. The table is actually a NIME specific format, but you can always convert it to whatever format you want. And some of these images I was talking about, and then what? Oh, some of the other things, like if anyone is actually using some kind of informatics, it has a lot of input for reading molecular files data. Okay, which is, I don't think any other open source tools has it actually. As in, there may be some of it which is specific for that chemistry labs, but this is actually kind of a general purpose, kind of a Swiss Army blade, right? NIME. It can be used for anything. And these external things, the Schrodinger's, and Pharmacilera. So these are actually from external agencies, but these are also integrated into NIME. These are kind of pharmaceutical specific data or the chemistry specific data. So what I'm saying is, it is not just one particular type of format, it can be several. All right, and the next one would be, okay, that would be, oh, actually we didn't, just 1 second. Okay, anyways, I want to go through the rest of the slides also. So the next one is actually, it is not only chaining up the multiple nodes together, you can also automate that workflow in several ways. So that is where this workflow automation and the flow control comes in. So the new nodes are either some kind of a looping nodes. So that would be either it can be a generic loop start. It starts with, suppose you want to read all the files in particular folder. So that was the example I was showing you here, showing you before. That was a generic loop start and a generic loop end. And then another one is, suppose you want to run the loop for a definite number of times. That's a counting loop. A group loop is, suppose you have several types of classes within a particular column. And if you want to apply that processing for all the classes in that particular column, that's a group loop. And then recursive loop is the looping will continue until the particular condition is met. So it is more like a while condition, right? And then switching. Switching is, suppose you have a giant workflow and you have multiple branches for the workflow. Several branches of the workflows can be activated or inactivated using the switches. So that can be if switch or case switch. If a particular condition is meeting, then a particular branch of the workflow will be executed. If not, the other branch will be executed, right? So that is a flow control. And then also another specific type of a flow control, which is actually called a flow variable. That is a parameterizing the workflow. Say you have one particular, for example, you want to see, okay, so if there is, if you are looking at the sales across the countries and you want to see which country has the largest sales for the quarter. So they say if the country is the column, and if that is the parameter, if you want to select it, and if you want to have this kind of report probably every month, right? You don't have to manually change it. The country which has that maximum sales, once you identify it in once, then that will be actually repeated. The country will be used as a parameter, and that parameter is actually flowing across that entire workflow. It's kind of easier to understand when you see it. I may have one example. And lastly, there is also an error handling. Suppose some part of the workflow did not really execute the way you wanted, or it did not really meet some particular condition, then that will be a breakpoint. So meaning that part of the workflow will not execute. Instead, the rest of it will be executed, or the entire workflow may come to a standstill. All right, let's. I think I may have something here. Let's see. So where was that? If loop, while loop. So let me also show you this one while we are here. Say this, like I said, this is the NIME Community Hub. You could search for any kind of a workflow. Okay, so this is one example. Whatever you see here, this is the workflow. You just drag it. Some of these examples, whatever I will be showing you here, this is all taken from this NIME Community Hub, right? And just execute it. So this will execute the entire workflow. So what this is showing, doing is, it is collecting all the columns and then replacing the column, doing some math, then changing the name of the column. And that way it is repeating that whole process. This is an older workflow. That's why you see this joiner node deprecated. The newer joiner node that has much more features. Anyway, so that collected all those data together, aggregated it, concatenated, and that's how you see finally. So this is one of those kind of looping function you see. And there are also other kind of looping, other kind of switches. We could actually, if you want, you could actually go there. Then, okay, so the next one is, this is an important component this is an important part of this NIME. Something called, see, like I said, each of those nodes has a particular functionality, but suppose you have several nodes together, and if you want to, once you start building the workflows, sometimes the workflows can be really huge. So you want to kind of keep it neat and tidy. So you can compact all that multiple nodes into one single node. So that kind of a packed kind of mini workflow within a single node. So that is called a meta node. And then another one called a component. That is also looks like meta node, but the advantage with that component is you can interact with it, meaning there are some of the other parameters you could select it. I will show you some of that examples. So the advantage here is, if you build a component, you can reuse it not only in your workflow, but you can also share it with other people in your team or even with the community, right? the community portal, which I had just shown you from within the name, that's where you could share it with the rest of the world. So if a lot of the functionality of the name is actually, at least the modern functionality of the name, is actually the components. So the components are freely available, so anyone can use it. Imagine this is a big function, okay? So a giant function wrapped into one cute little node-like thing. So that's the one which you can share. So let me show you an example. So see, these components. Suppose we go here. This is an example, and I'll be going through this particular example later. So what it does is AutoML. This is once you connect it to the data, it will run several models simultaneously, and it also pick the best model. It will also do the hyperparameter optimization. All of them is wrapped into just one meta node. But once you open that meta node, you will see that it is huge. Actually, we will go through that later. All right. So now let's go into the main part of the presentation, which is how do you use a NIME for ML or AI task. NIME has support for building, evaluating, deploying ML models, which include either it can be traditional algorithms like the logistic regression, random forest decision tree, or to somewhat more modern methods like the deep learning methods. And there are two classes, as you all know, supervised learning. If you want to, and supervised learning also can be within, if you know the name, if you know the label, if you know the output, then that would be the supervised learning. Regression would be if you want to predict one particular value, which is a continuous variable. Say, for example, the sale of a house or the salary of one particular person. So that would be regression methods. Again, I'm not the logistic regression, linear regression. Then the classification, it can be if it is for predicting any categorical outcome. Say, for example, if a person has a disease or not, or what type of a flower is it. So for that, it has a variety of algorithms. And then the unsupervised learning. So it doesn't have any particular label. You want to classify or kind of categorize a particular some amount of data into different distinct classes. Then that's a clustering method. You could either specify the number of the clusters or not. And the main thing is, regardless of what type of model you are using, NIME always uses two types of nodes for that. One called a learner node, the other one called a predictor node. Learner node is, NIME is learning about the data and building a model, right? And then predictor node is where that learned model is applied. And then seeing how well that model is performing. Okay, so those are the two different constructs. Let's go into the example here. I think I had one here. So that would be, yeah. Say, for example, it's a heart disease prediction model. This is the logistic regression model. And see, this is a learner node for the, this is where logistic regression learner is the one where it is actually learning about the data and then building a model. And then a built model is actually applied using this predictor node onto the other test data, right? So that's what I'm saying. Like, if it is a logistic regression model, then it has its own learner in the predictor node. If it is a random forest, it has its own, let's say, forest. Yeah, random forest learner predictor, tree ensemble learner predictor. So it comes in those pairs, right? If you are using one, then you also use the other one. All right. And then, okay, these are the types of models available. Again, just the overall classes of the models available. And then modeling is good, but again, modeling may not really give you the optimal accuracy or the optimal results if you are not massaging the data in some sense. That is called the feature engineering. I'm not talking about the data as in it's part of the data pre-processing, but at the same time, it is also somewhat distinct from it. So this can be selecting the distinct classes, types of columns you select. It can be either using the forward feature selection or the backward feature elimination methods, or it can be a combination, or some other methods. Then suppose the data is kind of all over the place in some sense, meaning there are some kind of, we are not talking about outliers we are removing it, but if the data is kind of in a in a in a broad canvas, meaning the range of the data is kind of huge, then you can actually normalize the data. I'm talking about the numerical data. So there are two methods, one called the z-score scaling. I think I had that one particular example here on the screen. Z-score scaling, so that will rescale the data to have a mean of 0 and a standard deviation of 1. The other one is min-max scaling. Also, that will be transforming the data to a fixed range. The problem with this this kind of a feature engineering is later it can be kind of somewhat harder to how do you say, explain this thing to a business stakeholder. For modeling, it will work really well. It might work really well. But finally, when you want to translate that insight to a business audience, it can be somewhat harder. It can be somewhat of a harder challenge, actually. Anyway, and then one-hot encoding. So that would be particularly valuable for some of this kind of classification tasks. And then this is the big thing, handling the imbalanced data set. Say a lot of these things we try to predict can be rare events. For example, if somebody's credit card transaction is fraudulent, or if someone has cancer or not, meaning it is not regularly occurring things, right? It's kind of a rare event. So predicting the rare event, that would be, say, if you have data for maybe 1,000 rows, and probably 10 of them may have, if it is a 10,000 rows of cancer data, only 1,000 rows may, only 10 rows or more, meaning fewer number of examples may be there for the rare example, which is the incidence of cancer or not. So when you use that data to build the model, even if the model has 90% accuracy overall, that may not be really good, meaning the model can always say normal in 100% of the cases. Still, it will be 90% accurate, right? So that's why you need to handle that imbalanced data before you actually build the model. So NIME has a lot of that kind of functionality built in. And now let's go to, yeah, I think I did. What was that? There was something here. I was talking about the scaling. Hmm. Oh, this is one particular example. See, this is a synthetic minority oversampling method. So this is an example of this particular workflow is trying to predict if a customer in the telecom company, if they will leave the company, if they will leave the service. That is called a churn. So the churn is a rare event. It doesn't happen, as in it is not the majority class, it's a minority class. So it has to oversample it. So that's what it is doing here, this mod. That is one particular functionality of that, what is it? Handling of this imbalanced data before that model is applied. All right. Now let's go into, where was it? Okay. How do you evaluate the model and interpret the models? So there are some of these nodes called the scorers. Actually, we will be going through some of that. Um, there are two types of scorer node. One is a JavaScript, which is a more modern node and which also looks pretty fancy in terms of its visuals. And there is also a numeric scorer. So that will be evaluating how well the model has performed. So that will give metrics like the confusion matrix. Confusion matrix is the number of false positives versus the number of false negatives, and that kind of ratio. Say how many of them were actually positive class, how many of them were actually negative class, versus how many of them were predicted to be positive and the negative class. So that is the confusion matrix. And then it also provides the accuracy statistics, like say precision recall, then the F1 score, that kind of metrics, right? That is for the classification models. But if it is a regression model, meaning you are trying to predict a particular continuous value, which would be probably actual income or the price of a house, then you use the regression metrics. That will be root mean square, um, that kind of stuff, or the R square. And then it also provides the regular visual evaluation methods, like that could be showing the true positive rate versus the false positive rate. It's the ROC curve. And there is also another special class of node called the binary classification inspector. That is, I don't know how valuable it is now, because there are also some other kind of components which has probably better functionality. And suppose you build this model. After you build this model, if you want to deploy it into a database, right? In a lot of the cases, if you want to bring in the data in NIME and then run all these workflows, apply the model. So that's where the time actually, it does take quite a bit of time, especially when the data is big. So that's why if you can convert that model to a universal currency, so that's called a predictive model markup language, and then bring that model back to the database. So that is where the you are almost instantaneously you are actually building um, you can almost instantaneously bring that prediction. If not instantaneously, at least you can reduce that the processing time substantially, because you are not really moving that data out of the database, and you are bringing in all that processing and also the model parameters in the form of another language, and then that PMML can even be converted to SQL, right? Which is the database language. I have not really worked with the PMML, but I've seen people using it. Okay. What else? Okay, so the next one. So this is where we would actually go through probably some of the slides a bit more. So usually the machine learning or the model building thing is kind of iterative. It is always iterative. And in a lot of the cases, you may have to work with this kind of individual pairs of models. Like say you want to test out maybe logistic regression, maybe a random forest, decision tree. So that you may have to do it individually. So instead of doing it individually, if you want to do everything at one go, which is the easier, faster way of doing it, then there is a component called the AutoML. And this was the one I was briefly showing you when I was sharing that NIME interface. So the advantage with this AutoML, which is a component which has so many functionalities packed inside that one, that will automatically train and select the best performing model, and will also tune the hyperparameters and then select the best possible setting of the hyperparameter, which is probably the best of the world. I have been using this one quite often actually in my work, because time is paramount. I don't usually have the luxury of time to work with a lot of the models individually. And then once you have identified a best performing model, you can potentially isolate it and then capture only that segment of the workflow which can be deployed as another workflow. Okay, so it's kind of harder to visualize when I say it. So maybe let me show you an example of the AutoML. Just 1 second. Okay, so this was, what was that? Yes, AutoML. See, the upper part, so that is the solving a regression task, meaning it has to predict a continuous number. What exactly is the state? Some data set. Oh, this is some kind of a weather data, and then also looking at, I forgot what was the data for, but anyway, this is a continuous thing. So it is trying to predict that this C and T, that's some kind of a count. I don't know what exactly is it, but anyway, this is the whole point is it's a continuous variable. And then you are partitioning the data into two halves. This is the training and the test. And then see, it looks very simple, but if you go into that, this is the component, and the advantage of the component is, like I said before, you can set the parameters here, right? So these are the include, the exclude is the features or the columns you will exclude, and the include is the features you want to include in the model. And these are the different models to train. And what will be the target column? What do you want to predict? So here you want to predict the count. And what will be the metric for selecting the model? So here it was set as root mean square, square error. You can also select any of these R square. And then how many fold in the cross validation you want to do it. Like usually it is default, it is set at 4, but sometimes people set it at 5. So essentially the test data, the training data, you segment into 4 distinct segments, and then run these models each time, and then output the data, right? So that is, so how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 models you are running at the same time. And then it is picking up the best performing model. But see, it may look very simple, but if you go into that one, if you open this component, there are several components nested within that component. So if you have seen Russian dolls, like one doll, one large doll, and inside that one other smaller doll, and a smaller doll inside, another smaller doll inside. So it is like that. It is, see, the AutoML, when I opened it, there is another component here for configuring, post-processing the configuration. This is actually another component, okay? And then data preparation is another component. So suppose you open that one. See, this is another workflow. And within that one, there is another component. So it keeps going, but you don't really see any of that outside. Essentially, it is abstracting away all that complexity in that one particular, in just one node, which is actually a component. And then here is the component, another component where it's bringing in all that particular, those models. Each of these model itself is another component, right? So some of these models may take a long time to run. For example, the XGBoost linear, actually XGBoost free ensemble. So that does take, as is deep learning. These ones do take quite a bit of time to run, but these are kind of toy data sets. So that's why it did take, it didn't take that long. But if you have a really large, I'm talking about enterprise level data, then some of these check boxes you might want to check off, because it does take quite a bit. We are talking about running it overnight or something, but it may not completely finish. Okay, so that was the whole point. Like this is a AutoML component node, and component node can have multiple components within nested inside, and this component can abstract away all those complexities and making it easier for the user to use it. So what you had seen before, so that was a regression AutoML. Why don't we execute it? This was a scorer thing I was talking about. Root mean squared error. So essentially it is looking for a model which produces the least error. Okay, so that is for the regression model. And then the classification model, it's a different set of models. So here it is, some of them are similar, but the random forest decision tree these are unique for that. Neural network that might take sometimes longer to run, but may not always be as effective as some of the other models. And here, income is actually, even though it is mentioned income is actually a bucket of income, like between 30 to 40,000 or something. So it is actually a class rather than a continuous variable. So here also you have 10 sets of models you could run simultaneously, right? And get the outcome. So here, this is how it looks like. These are the different types of metrics. How many true positives, false positives, true negatives, false negatives. Recall precision, sensitivity would be the same as recall. And then the F1 measure, the F1 score, they call it F measure. It's actually the mean between the precision and the recall, then the accuracy of the overall model. The coherence kappa is particularly good for the kind of imbalanced data set. I don't know if it is actually imbalanced data, but anyway, that's when people actually tend to use it more, but which also is kind of hard to predict, hard to explain. And yeah, so that was about the, someone, anyway. Yeah, that was about the general classes of the models. And now let's go into the another class of models, which is the deep learning. Here, it is integrated with the other popular frameworks. It's actually built on the other popular frameworks, particularly Keras, which in turn it's built on TensorFlow and also PyTorch. Okay, this also had NIME was probably one of the first to, at least this kind of in a visual interface, to develop their own custom neural network model. And then later they had ported the capabilities from Keras and PyTorch. There were the two classes, convolutional neural network, recurrent neural network. So these things are not really that cool anymore because of the large language models now, and also the other, the PyTorch functionality which is standalone. But like I said, this can all be brought here. Even those capabilities which are not really built into NIME, those also can be brought to NIME using that script node. So if you want to classify an image, for example, an X-ray image or any kind of image, actually, that's when the convolutional neural networks are brought in. Or the recurrent neural networks is for the time series data, for the maybe EEG or ECG, or the market fluctuations, right? So that is when you use that one. But in addition to this, you could also, there is also the capability to bring in a lot of other models from the other ecosystems. We are talking about this big ecosystem called Hugging Face. NIME has the connectors, the Hugging Face, so you can bring in whatever you want from Hugging Face. Yeah, so probably I think I may have an example. Let's see. Okay, this one was BERT. No, not that. This one. Yeah. So this is a BERT model is not new anymore. BERT was new. When was it? I think 2017 or so. That's when Google published that paper. This is bidirectional encoding. Oh my gosh, I forgot. Bidirectional encoding of representations by transformers. That's what BERT stands for. And this is connecting to TensorFlow Hub, but you can also connect it to Hugging Face. Hugging Face, now it has, I think, close to 1.5, probably close to 2 million models. When I started looking into it 3-4 years ago, it was only 40,000 models. But see, it's a huge exploding ecosystem, really. So essentially, you could bring in all that capability here. So that's what I'm saying. Like, it is actually siphoning the power of the other open source initiatives into the NIME platform. Okay, so here it is selecting. It's actually some French text classifying using a birth model from a specific ecosystem, and then using that, classifying it. So similar, using the similar kind of paradigm, which is a learner node and the predictor node. So it's a similar motif, and then calculating the outcome output, showing the prediction output. Right. Okay. So the whole point is, it is not just the older models, but also it also gives that access to the newer models in other ecosystems. And oh yeah, the next one would be explainable AI. See, all this modeling is, everything is so good, but if you cannot really, the business won't really take a lot of your models very seriously unless you can actually explain it in their language, really. So that is where, what do you say, this particular segment comes to the rescue to some extent. So there are different types of explainable AI methods. Like it can be, and the main thing is, usually the explainable AI can be kind of hard to implement, but here it is a no-code approach. So you can actually see a lot of this kind of explainable AI methods packed into, again, one component. Just like the AutoML, you have multiple XAI methods packed into one component. So it can be a global explanation, meaning what do you say? How the different features are contributing to the performance of the model, which of those features were most important. And then it can be local, or if you change the this particular feature to this much extent, then the model, then the prediction would change. Example would be, suppose you are applying for a loan and your loan is denied. So they will say, oh, you had to have a minimum income of, if you could increase your minimum income to maybe another $10,000 or whatever, then you would get the loan. So that would be a local explanation, right? And then there are specific types of methods that would be whatever is listed here. LIME, that is a local interpretable model agnostic explanation, which can be applied to any model. Then Shapley values. So that would be which of the features contribute to the most. So that actually comes from the game theory. I forgot the actual how they really calculated, but it is implemented kind of really simply in NIME. So there are methods for both the global and the local explainable AI. Let me show you some. Let's see. You know what happened? Oh, right here. Yes. This is a customer churn, which we had briefly touched on before. And then it is trying to, it is trying to explain that model using both the global feature importance and the local explanation. So see, this is also a meta node. Meta node. So these are two different, there are 4 different methods, but it is selecting just the 2 different methods. You could select just one if you want. So permutation feature importance is you are shuffling all the features, and then if the feature shuffling has substantially reduced the mode of performance, then that feature is deemed important. So that's a permutation feature importance. Surrogate random forest is, it is essentially building a surrogate on that previously existing model. How do I explain that one? Just one second. I don't know how do I explain that one. But anyway, like it actually gives the two different ways of explaining the model in a global sense. So let's look into that. Okay. It also gives that the interactive view. Yeah. So the upper part, see, it is actually giving the listing of those the different features. So days in the minute, the minutes in the day, and the charge per the day. So those were the top two features. Um, and if you also look at the third feature, which is the calls to the customer service, so those were the three top three features which were important for the model to predict a customer as leaving or a customer churning. That is, churn equals 1. And the other method, which is actually shuffling those models, shuffling those features. So when a feature is shuffled and if the model really suffers, then that means that particular feature is important. Using that method, um, it is finding out the same uh, three features which was found important in the previous method, in the above method also. So it was minutes in the day, charge during the day, and um, calls to the customer service. But here, it's the same, even though it is the same thing, the order, the ranking has changed, right? So uh, apparently for this kind of a method, the permutation feature importance is probably more suitable. That is some of the recommendations actually. So it's the same, it's the same features, but the ranking has changed. That's it. But otherwise, it generally shows uh, quite a bit of agreement, except this kind of lower ranked features. Okay, um, that was the global feature importance, meaning which of these features were important for the model as a whole. Now, if you want to predict, um, if you want to explain why one particular instance of a prediction was made, meaning why particular customer was predicted to churn, then that is um, the local explanation view. So these are the local feature importance that shows the whatever you see it in green. So that is showing that the customer it is, these are the features which are strongly positively correlated to the customer leaving. The other one is negatively correlated to the customer leaving, right? So evening charge is not really that important in predicting. As an evening charge, it will not, it will go the opposite, right? And then it is also giving a few examples, specific examples of the model's prediction um, versus the actual, meaning these two examples are the model had predicted that the member would churn, but um, the model had predicted the member would, the customer would stay, will not leave, but they actually left. And then another example showing the model predicted that the customer would stay, and he in fact stayed. He did not leave, and it is actually showing those kind of how do you say, the the changes in the values for each of those features. So this will kind of inform you if you want what of this kind of metrics you want to change. Say, do you want to um, if you want to, if you are changing, if you are increasing or decreasing the service charge for some particular day, or day charge or the night charge, how it might affect it, right? So I think that's how it is explained. Anyway, so this is some of the things which may be useful for a customer-facing business. In insurance also, that's where I kind of work. We don't really go to this level actually, not to individual level, because that is sometimes it may work, a lot of the times it doesn't work. So it also depends on the appetite for risk for the business. Say some particular examples, like if a customer will leave or stay, that may not be as highly risky as compared to if a patient has cancer or not. And then if you're predicting this particular, if the model is predicting, oh, this individual has cancer, then needs probably some kind of a surgery. So that is a highly risky, how do you say, scenario. So that's where I don't think they even actually deploy this kind of models. because that is where a human intervention has to take place. All right. Otherwise, for recommender system like movie watching, that is not really, say, Netflix recommender. That may not be a um, high stakes scenario compared to somebody having a disease. All right. So that was about the explainable AI. Oh, and there is also another node. Not the node. It's called a component. Just like the AutoML, there is another one called XAI, and you could just drag and drop from the NIME community forum and just connect it. So, say for example, you want to maybe apply it here. I don't want to run it because I don't know how long it would take. And then maybe here, this would be here. So this is actually both the global and the local explanations packed into one node, right? So that's a clear view. And let's you just say what do you want to explain? Is it not churning or churning? And then it is applying that model to the training at the test data and then explaining for some of the samples. So here it is actually it has a data limit. I think it takes probably 100 samples or something. If it is anything more than that, then it will error out. Probably it's already erroring out, I think. Yeah. Anyway, so this was a demonstration just to show that you don't have to build everything from scratch. You can always get a lot of the stuff from the community hub, including workflows or the components or some other additional functionality. So this is a rich repository of a lot of the stuff of in NIME. And now, okay, the next step. This is a kind of a, as in it's not really that new, except the newer methods. The NLP methods were there for quite some time, actually. Initially, starting off with that bag of words method, and then later building on the bag of words, then it had started off with the first, I think, the reliable topic detection method, which we still use, is something called latent dictionary allocation, LDA. So LDA essentially is a unsupervised classification method. So it is looking for the clusters in the text data. So if you have a lot of text and if you want to identify what are the themes in this particular text, that is where you apply LDA. This is an older method, actually, even though people are still using it. In our team, we have been using it. And this has a particular component called parallel LDA node. So that's where you can, it will create the topics for you. But the main problem with this method, first thing, it is old. Second thing, it also does not really label the topics. It will just say topic 0, topic 1, topic 2, 3, like that. And then in the last couple of years, the transformer models have really gained up a lot of steam, especially the birth maze model. And a lot of this, the transformer models now are available in NIME through the Hugging Face connector, right? And that's what I was demonstrating some time ago, like the birth. And probably towards the end of this presentation, maybe I would also look up the, how do you say, I will show you that more modern user interface, not the legacy. That is where you could actually, how do you say, see that first thing, that interface is kind of easier to the eye, and it also has some of this kind of built-in AI features. But let me, probably I'm jumping a little bit ahead. And these are some of this kind of native capabilities, and also some of this kind of capabilities which are from outside. And so, in a similar vein, NIME also allows integration with other integration in the sense, this is what I was talking about before, like it can take additional functionality from other platforms like, say, R or Python. And it can, NIME Nime will automatically create its own conda environment for whatever Python environment you need. Essentially, it's more like in that either with the VNV or the conda method of creation in the Visual Studio Code, that it is actually much simpler here. And you could create the environment either for the CPU or for the GPU if you have standalone GPU. And then you could also integrate your own Jupyter. Yeah, go ahead.
Sir, we have a question in the chat box.
Oh, I didn't hear. Yeah.
The first one is, can we see visualizations or plotting graphs in Nime?
Yes.
The first question.
Yeah. Okay. And do I go there or do I wait for the rest of the questions? Let me show you some examples. This is a scatter plot. I think I also had another. Yeah. Actually, I was about. Wait. What is happening here? Image data. Oh, interactive view, scatter plot. This is a scatter plot. So like that, there are several methods. Like I think I also had another one called a sunburst. Either you could use its own built-in native visualizations, or you could also bring in the external capabilities. Let me show you a sunburst chart, which is not, you don't really see it that often. I'm talking about in platforms like Tableau. It's not really easy to make it, right? And this is so that is one of the advantages here. You may have some of these kind of not really usual graphs, sunburst or the sand key diagram. In Power BI, it is easier to make a sand key. I don't know if they have a sand key here. Sand key is if you want to show the flow of, say for example, maybe a million members are calling, and what is their call pattern? Where do they go from where to where? Okay, so I don't know if they have it. Oh yeah, actually they have. I didn't know they had this one. It's kind of relatively new. So it's a component where you could actually bring it in and then process the data, so you can actually get the sand key. Sand key would I don't know if you. Anyway, so I don't know if it answered the question. So this is another sunburst. So it can be a sunburst. It can be a variety of this kind of JavaScript based visualization, and it also has some of this kind of D3 visualization, which is again built in JavaScript. So that did it answer the question, or was there something more? Because I cannot really see the screen because I'm looking at the other one. Did it answer the question, or was there something more? Let me also look at the other chat.
Yes, sir. The chat has come that it is answered.
Oh, okay.
Thank you, sir.
Yeah.
Sir?
In Nime, what type of optimizers such as Adam are available for training deep learning models?
Yes.
How can be configured with their workflow? Okay, all right. So let me go there. Just 1 second. This would be, you know what, deep learning. One of the reasons I did not really bring in any deep learning workflow here is it does take some time. Building sentiment predictor. Let's see, probably here. Hope it works. Okay. Where was it? You could actually, I don't know, where was it? Specify what type of optimizer you want. There was, I don't know, where was it? It was in one of the components. So essentially a lot of this kind of functionality was packed into one node, which was a component. This, I don't know if it is, let's see. It's not, let's see. No, not here. Not here. I don't, but yeah, you could specify what type of optimizer you want. There was a component, but I don't quite recall where it is. So I would share all these resources with you, so you could actually explore at your own leisure, right? The short answer is yes. All right. So let's go to. I have a few more slides actually. Was it? Oh, and then am I sharing the screen? I'm sharing it. I don't know why I don't see it. This thing. Okay. All right. And then lastly, it's not really last. There is okay. Actually, data visualization and reporting deployment. Probably I will skip that since I just mentioned
Pardon
that.
me, sir. Pardon me, sir.
Yeah,
We
yeah.
have
Go ahead.
another question also in the chat box.
Okay.
In NIME, can we design a hybrid model by combining with different machine learning models?
Yes. Yes. So that would be one example. Is say, are you talking about an ensemble method, or you are talking about just bringing in different types of models altogether? Let me see the chat. Just 1 second. A hybrid model by combining with different machine. I'm assuming that it is bringing in multiple models. One of the methods, like I was saying, is either you could use that AutoML. It is not really a hybrid. It is just running several at the same time, or you could combine you could essentially use the output of that model to create an ensemble model. So generally ensemble models are sometimes can be better. Like you have finally, how do you say, zeroed in on some particular model, and then you also have some other model. You combine the best features of that, right? So that is possible, yes. And also, oh, actually, you know what? I don't think I can show you here, but there is also this concept of the model factory. Um, so you can have multiple models, and you also build challenger models, and say you have a running a production workflow. Okay, so this particular example I had seen for a um, predicting the candidate drug molecules. So they had this, I think it was in Novartis. So they had this huge pipeline, and they are testing out um, hundreds of thousands of molecules for a candidate to be a candidate drug molecule. Um, they had, I don't know, probably 10 different models, each with multiple parameters tuned. So essentially, it is, if you consider each one of them as a different model, so that'll be close to about 12,000 different models running at the same time, right? But it is also creating a challenger model. And it is also running a challenger model in parallel. And wherever the challenger model is performing better than the model which is in production, then that will be automatically picked up without the user intervention. And then that particular challenger model is applied going forward until another challenger model performs better. And that was a demonstration which was done in sometime 2018 by Novartis. And since then, they have made a lot of changes. It will be somewhat similar to MLflow. You have your own kind of experiments, but I think NIME was one of the first to show that. Essentially, there was also a demonstration. One particular data scientist or two data scientists, they were looking at the customer interactions through multiple portals. We are talking about, say, it was somewhere in the Netherlands, multiple portals. It would be either making a reservation in the hotel or doing some kind of a credit card transactions, or making a airline reservation, or making the calls about it. So all types of customer touch points. And then they were trying to predict what would be the best time to serve the customer, and also a host of other kind of parameters, like if the customer will stay or not, who would be the most loyal or not, and what type of loyalty program they had to offer. Everything was done with this kind of a model factory, which was maintained by just two data scientists. And essentially, they were serving a customer base of about 8 million members. So I think I went a bit tangent, but definitely the capabilities are kind of up to the imagination, really. One node would be suitable after another node. How do we create a book? Oh, yeah. So am I sharing the screen? or I'm not.
Sir, you're sharing the screen. It's
All right,
visible.
okay.
Yes.
And it is the name you're seeing, right? So one of the things is, see the workflow coach on the left, right? So that is the one which kind of advises you on which node to use after another. But a better way. So now since we are coming towards the end of the presentation, let me go to the open NIME NIME modern user interface, right? So go there and oh, please. Okay. So I will have to reopen all. Please, what is happening here? No. Okay. Yeah. So suppose I go here, and then this is called KAI. That is NIME AI Assistant. My other meeting is starting, so I will be stopping in about 5 minutes. So this is your own AI assistant. So it'll be, if you have used Visual Studio with the GitHub Copilot installed, it is somewhat similar to it, as in it's not really as powerful as that. But here there are two different functions. One is you can ask questions. I need to create a workflow for um, um, maybe predicting something, whatever, and then then it will give the I need to build a workflow um, to predict churn. So it will answer your question, and it will give some of the suggestions, right? So these are the different kind of things you could do. That will be the suggestions, just like the chat mode in the VS Code GitHub Copilot. And then next text message is too large. Anyway, the other one is it will give the suggestions on how do you actually build it. So that is in the build mode, right? So this is actually much better than the previous the community poll on which particular node you had to use it. But this is actually far more valuable, really. So I would suggest you go here. And let me come to the end of the presentation. Just one second. NLP, yeah, this was the one I was talking about. Ask KI, large language. This is also the same thing. And data visualization, we would skip it because this is one I had mentioned. And then there is also this part called NIME reporting extension. Then the last step, NIME value proposition. So essentially, it is empowering the users from the beginners to the experts. So the barrier to entry is really low. It is also very transparent. It is also explainable because the code is open source. It is extensible, and it promotes collaboration. Everything else, right? So why is it valuable for the data science education? That you can focus on the concepts rather than being bogged down by the coding skills required. And then since it is a visually document, since it is a visual workflow, the documentation is also kind of built in some sense. And it is bridging the skill gap, meaning essentially it is creating a new batch of the citizen data scientists. There was this big program in Jupyter Networks and also in Samsung. They are creating their own huge armies of these citizen data scientists. So and also it will probably prepare the students faster for the industry. So that will be the data proposition, the value proposition of NIME. And then these are the different sources, especially go to Community Hub, and also the Learning Hub. That is where you could actually learn about NIME. You could get their free courses. You can even be certified. Sometimes they give you the free certification training if you attend one of their summits, which is all free or online free. Online, if it is online, it's free. And then they also have some of this kind of NIME Press. Some of those booklets or the even introductory books are for free. So please do go there. Okay, I think that's it. Thank you.
Thank you so much, sir. Since, as sir mentioned, another meeting is scheduled for him, we'll be not going to the Q&A session. I hope the questions that we asked in between and the answers were clear for that. So now I think it's time to express our gratitude towards Melvin sir. Melvi sir. On behalf of all participants, I extend my heartfelt thanks to Dr. Melvi Midipara for insightful session on AI and data science with NIME, a no or low code open source platform. Your session has made complex concept approachable and highlighted how tools like NIME can empower us to explore data in innovative ways. Thank you so much, sir, for sparing your expertise and time to enlighten us. Thank you so much.
Thank you for having me. Have a good day, everyone. Bye-bye.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you.
Thank you.
Thank you.
Bye-bye. Bye-bye.
Bye, sir. Good night. Bye.
And dear participants, it's time to wind up today's FDP. Thank
Alina.
you all for attending.
Okay, I would like to mention that in between. Thank you, Alina, so much. Thank you so much for moderating the sessions. So dear participants, thank you so much for joining us. A gentle reminder, the feedback form was shared in the chat box. Kindly fill the feedback form. At the same time, a reflection journal document was shared in your WhatsApp chat for our FDP group. Kindly fill the reflection journal document, convert it to PDF with a maximum of 2 MB size, and upload it in the Google form that has been provided to you in the WhatsApp group. So you can come, you have time till tomorrow to complete it. And regarding tomorrow's sessions, our session starts at 2 p.m. 2 to 3:30 is a session 1, 3:30 to 5, second session, 5 to 6:30 is a third session. And at 6:30, after the session, we'll be having a very short validatory function. Followed by the validatory function, we'll be having the online test. The online exam will be conducted through Google Form, and the link for the Google Form will be shared in the chat box in our Meet. Duration of the exam will be 1 hour. So kindly join us, dear participants, at 2 p.m. tomorrow. Thank you so much for joining us for the past 5 days. We are indeed grateful for all your contributions and your presence. Have a good day, good night, and take care. Thank you so much.